All right, looks like we are live, and I want to welcome everybody to Standing for Truth. My name is Donny, and I am your host and moderator for tonight's much anticipated Great Age of the Earth debate between Matt and Grayson from the Based Theory YouTube channel. I am pumped for tonight's debate. One could say this is Clash of the Titans, and I have I've made it mandatory that both Grayson and Matt bring the heat tonight. This is a Friday night showdown. So why don't we get acquainted, though, kind of break the ice a little bit before we get into the opening statements. And Matt, let's start with you, as it has been a little while since you've done a formal debate, that is. And so appreciate you being willing to engage in the Age of the Earth debate. So Matt, how you doing today? And also a little bit about yourself.
I'm doing good. I'm excited to be doing this again. Haven't had a debate since Jackson Rowe on extreme longevity, and then got busy. You know how life is, and my channel's just been kind of held up because of you actually uploading things from your videos, because I haven't been able to edit or do anything. So now it's time to debate, and I'm doing the first one ever on the Age of the Earth. So should be interesting.
Yes, this should be interesting. And we've been re-premiering a lot of content, a lot of debates over on your channel, the Young Earth Creation channel. And so it's good to have you back in the debate octagon. Grayson, also great to have you here as well. Always a privilege. You're kind of one of the top dogs currently in the evolution debate world. And so appreciate you being here and being willing to engage in this topic. And so how have you been? How's your June so far? And then also a little bit about your channel, Based Theory.
Yeah, thanks, Donny. Yeah, it's been good so far. It's been a minute since I've been on here for a debate, so I'm happy to be back on. I was getting a little, itch to go back into the ring. So normally I am a very soft and quiet individual. So we'll see if I can try to turn on the heat for this debate here. Maybe be a little bit more assertive and opinionated. We'll see if I can do it. My channel is Based Theory. I do lots of debates, not only with young Earth creationists, but just anything that is pseudoscientific. And I also do videos where I just discuss really cool and interesting ideas in science and history. So check it out if any of that sounds appealing to you.
Awesome. Thank you, Grayson. To the audience, if you like what you're hearing from Grayson over at Base Theory, make sure to check the description box. His channel link should be linked there for people to go over and see. Matt, of course, is associated with Team Standing for Truth. So if you want to see more from him, well, you're here on the Standing for Truth channel. So make sure to check it out. You're both certainly no strangers to debates. Grayson, at this point, you must have at least done 20 at this point, if I had to guess. And although it's been a minute, as you pointed out, since you've been here, we do have you scheduled for at least a couple more debates coming up. I'm excited for this. Yes, to the audience, this is our first geocentrism debate on Standing for Truth. And so we've hosted now over 320 debates on all sorts of topics. But again, this will be the first for geocentrism, and what a debate we have. Dr. Robertson Jenis and Grayson both know their stuff on this topic. And so this is coming up, if I'm not mistaken, in about a week. So you're definitely not going to want to miss out on this one. Last night, we had Paul Price and Michael, the Canadian atheist. They discussed evidence for God. And we've got another one coming up in a couple weeks or so. Is there evidence for the existence of God? Again, Grayson. So Grayson will be here. Paul Price. This is going to be a fantastic discussion, I can predict already. And Matt is going to be busy as well. So he's going to be here taking on Mark Reed. This is in a couple weeks as well. Is there scientific evidence for evolution? But we are here tonight for the Great Age of the Earth debate, Matt versus Grayson. And Matt is more or less taking the affirmative tonight, and therefore we are going to give him the floor for the first opening statement. So for the audience sake, we're going to have opening statements of about 10 minutes, and then we're going to just jump right into discussion. And so a lot of people, they've enjoyed the more free-flowing nature of these debates, and so we're just going to have a lot of discussion on the topic. And then once we've exhausted the topic, and there's nothing more to chat about, we will take some audience questions. So please, if you do have a question for either Matt or Grayson. Let me know who the question is for. Say, hey, question for Grayson, question for Matt. Tag me and let me know what the question is. We'll have some fun. Okay, so with that, Matt, whenever you're ready, you just let me know, and we're going to give you the floor. You got about 10 minutes. Here we go.
All right. Screen share for me, and we will get this going. All right. So hopefully everyone can hear good. All right.
Yes.
What you're looking at is there's many type of people out there. We fall into the category of young earth creation. And surprisingly, we are the majority when it comes to that. We are catastrophists. Secular scientists are taught uniformitarianism in school. So that's by the default what we learn. And so the difference really comes down to how do we view the past. When it comes to dating the age of the Earth, there's only one tool for that. It's radiometric dating. When we want to know about the deep ice cores, radiometric dating. Want to know the age of a moon? Radiometric dating. Age of the meteors? Radiometric dating. You get the picture. Until now, these dates have not favored young Earth creation. As a matter of fact, both heat problems from two of the most popular young Earth creation flood models exist trying to deal with radiometric dates that they give. That said, there are some assumptions that go into radiometric dating. There are 8 major ones that actually go into this. And until recently, none of them could be actually validated. And it's because of this, these assumptions, that statements like this abound. And we'll not go over this because of time. But as you can see, there are problems, and they're all based on starting assumptions. So don't forget, I like radiometric dating. I think it's a tool that's one of the best ways that we can actually measure time. So when something is happening in the past or the future, I actually agree with them. I like them. I'm a rare case in the young Earth creation world for that. So that being said, we are going to focus on problem number 2. And that's the second one. And that is going to be our focus of today's debate. And that is when they form, what is it like? So we need to know the Proton 21 laboratories in Ukraine. That's going to be a focal point for this one. Unfortunately, this place exists in one of the worst places in the world as of right now because of a war that's breaking out. But regardless of that, they're working with cold fusion, and they're creating super heavy elements using something called Z-pinch. And this is where it gets really amazing, because one of the scientists that is now working there, before he was, began working with formations of iron. Now, what I mean by this is that he was able to create the exact ratio and proportions of iron that we have on Earth today from an experiment. Once this formed, we compared that and we were absolutely shocked. And he got a job working over at the Proton 21 laboratory. So he brought his experience and education into that. And now the elements that have been created at that place, again, match what we see on Earth. But even more interesting is that the daughter elements formed at extremely high amounts of, or a high ratio, higher than we would ever expect. But it's because their decay rate is so fast, they vanish in a few hours or days, for example. So what happened is this got the scientist into thinking, like, how are we going to utilize the high amounts of these daughter elements being produced? Like, what can we do with this? So their goal became that we're going to form high amounts of 3 particular radioactive elements: Titanium 99, Iodine 131, and Lutetium 177, which are used for medical cancer imaging research. So that's what the focus is now in that laboratory. So that got me thinking. I'm like, wait a minute, this got my attention, because what about the ratios for other radioactive elements that we use to date the age of the Earth? So this made me jump right over to aluminum-26, which has a short half-life isotope ratio of just 730,000 years. So what's it doing in such high amounts, but not just in the Milky Way galaxy, but even on Earth itself? So the scientists tried to solve this paradox that's going on, and they thought maybe the formation was via cosmic rays from the sun. But the problem is the sun couldn't have made that many cosmic rays for the requirement that's in such a high amount in today's world in such a short amount of time. So they came up with another idea. And this was, well, maybe there was a cosmic burst from a supernova that produced massive amounts of it very, very recently. The only problem with that is they've actually shown that supernovas can't produce anything over a lead. So it can't even produce the aluminum that would have been required for this scenario to have taken place. So they can, I say, throw in any rescue device that they want. But the fact is that when we look at the very formation of these things, so even the aluminum-26, we're finding that the observational data matches what we see in the laboratory. So that's what's amazing about this is it solves the paradoxes for evolution. And I think that's a great thing as well. But of course, it reduces the age of the Earth to an upper limit of 740,000 years maximum because of that. And then so it made me go over and look at potassium. Lo and behold, potassium ratios are exactly the same that we see on Earth today in the same proportions that we see on Earth today. This again would set the upper limit looking at potassium to just 1.25 billion years by looking at that ratio, let alone 4.56, which is the age of the Earth. That brings us to the next piece of evidence, which would be the lead paradox. Now, this is interesting because we have more radiogenic lead isotopes than there should be, unless, of course, you can see right here on the right side that they said unless the Earth formed 13.9 billion years ago, or 100 million years after the formation of the universe itself. So obviously, this is a huge problem. And that can only be resolved through either accelerated nuclear decay or by the observational formation of these elements. Obviously, I'm going to go with that one myself. But the paradox is actually made worse by the new discovery that just happened, I think, this month, when they finally broke down into the mantle for the very first time ever. And they pulled up results that actually showed there's not much lead down there. There's far less than was expected and not more. And it's radiogenic as well. So I would think that this is solves that paradox because it's being formed in the ways that we're seeing it. So I believe this also explains the distribution of the radioactive elements that we see on Earth today that don't make any evolutionary sense why uranium and thorium are on the crust of the Earth and not deep within the Earth, especially since they're so heavy they would have sunk to the core, or they would have already kind of been in the core because they're powering and creating the power to rotate the Earth itself. But there's also another paradoxes, right? 33%, or I'm sorry, over 50% of all radioactive materials exist just in Australia alone, as you can see from this map, and 90% of all uranium and thorium is just in Australia. So it's very disproportionate of what would ever be expected. So another analogy would be, I made all of these clocks last week that you can see right here, but they tick at different rates. There's also clocks inside of clocks that also tick at different rates. No one would have ever expected the daughter elements to form as they are today. Not even us young Earth creationists would have actually predicted this. So that's probably why this is the first time you're hearing about this. So it comes down to what was expected, which was what the evolutionary community would have expected to find: uranium slowly decaying into thorium and iridium and radon. But what we actually found was more indicative of what the experiment showed, that they actually form at exactly the same time in the proportions and ratios that we see today, the exact opposite of the evolutionary prediction. So at first glance, if you were to actually see these clocks in the ground, you would think, well, they're ticking at a constant rate. So obviously, if we take that assumption and we go backwards in time, we can just reverse these clocks and it would tell us the true accurate history. While true on the surface, the most important question that we needed to ask ourselves before agreeing to that idea is, what happens if we do go backwards and we run out of history? The clocks are still giving it a time frame, but we actually can't judge it off of that. So I could say that I made these clocks last week, and they do tell time perfectly. So I placed these into a computer game from the very start, or the dawn of the program, and all the NPCs using these clocks, and they came up with the same idea that we did. Like, maybe we can reverse these and find out how old something is. But they would need to read the manual to learn that I actually created these just a week ago. And I believe that the Bible is the manual for us that we use to tell us how old something is. And we go with these genealogies back in time, and it's not that old. So the same analogy applies today. I think we can tell accurate time, that they must be able to tell us accurate history. But if you're using them to tell a time about history that doesn't exist, then we have a problem. And that's exactly what happened based upon the most recent concept of evolution. I think they came in with a preconceived notion to begin with, and then they just kind of ran with that by saying, well, if we find this many daughter isotopes, then this much time must have passed. So one final analogy is that I guess I could reiterate my position with which out of all of these clocks tells better time. Well, they actually all tell really good time. But as I said, I only created them last week. So even though they all have the capacity to tell perfect time, even going backwards, we cannot use them to tell us when they formed unless we know some important factors. When these elements formed, what were their parent to daughter isotope ratios? That's the golden question. And today, my goal is to answer that. So then we're going to conclude with we have the formation of both non-radioactive and radioactive elements being formed in the same proportions and ratios that are on the Earth today. The radioactive elements form with both parent to daughter isotopes in the radioactive, or in the ratios that we find them today. We have the lead paradox, which is solved by either accelerated nuclear decay or the observations made in laboratory experiments, which shows that when lead forms, it exists as it does today, not billions of years ago. It solves the lead paradox. The new discoveries of the rocks in the mantle add further problems for the lead paradox, but it doesn't really matter for us. The new data solves these paradoxes, and but the only caveat to that is it shows that the Earth is young. So if these elements formed just thousands of years ago in the exact ratio that we see them in today in the laboratory, then why assume they represent billions of years of decay? You can't. If they formed in ratios completely different than today, then sure, you have a great case against me and for eons of time passing. But since we now have observational, physical, repeatable, testable evidence on the contrary, Earth can't be old, and the evidence solves these paradoxes that exist in cosmology as well. So it seems to me that you can either accept the observational data that solves the evolutionary paradoxes or reject it, all because it confirms young Earth creation. My goal is that I hope you choose the logical scientific view on this one and go with what's been discovered. And I guess that does it for my opening.
All right, Matt, thank you very much for that opening statement.
I went fast. Sorry, I need a drink.
Yes, you've earned yourself a drink. I know these opening statements fly by. To the audience, I see already questions flying in, so I appreciate it. Yes, I am all caught up on questions. And so thanks for keeping the questions on topic. That was exactly 11 minutes. And so to be fair, before we get into the discussion, Grayson, we're going to give you equal time for response or introductory comments. And so whenever you're ready, go ahead. 11 minutes.
Okay, cool. So yeah, Matt covered a lot of material there. There's a lot of things that I would like to address. I'm trying to think about which order would be best to start this in. I think I'll just start with the assumptions. He said that there are 8 assumptions inherent in radiometric dating. He didn't really go into what those 8 assumptions are. Maybe we could go by them one by one if he wants to. But the key for these assumptions, right, is that they're different for different radiometric methods. The assumptions inherent in carbon-14 dating are different than in like oxygen isotopes or in like argon potassium or in uranium dating. Each one of these makes different independent assumptions about like initial conditions, and the rationale is different. Those assumptions are different. They don't have anything to do with each other. The reason for the assumptions about the initial conditions in carbon-14 dating are completely different and unrelated to those for the initial conditions of uranium-lead dating. So the fact that all of these different dating methods using these different elements all overlap, and we can actually like corroborate them with each other, that would substantiate their veracity. So maybe we can go into specifics about what these so-called assumptions are, these 8 assumptions, and maybe we can go by them and we can discuss them. But so far, I didn't hear what those assumptions actually are. I did hear this analogy of a clock, which, yes, radiometric dating is, or radiometric decay is in some ways like a clock. However, it is not a perfect analogy. For example, you can make a clock at any starting time that you want, but you can't necessarily make a zircon crystal at any composition of lead and uranium. Zircon crystals do not form containing any significant amount of lead. I would welcome Matt to show an example of a zircon crystal forming with any appreciable amount of initial starting lead, because to my knowledge, every single zircon crystal does not form with lead, because the lead does not naturally incorporate into the crystal structure of the uranium of the zircon upon formation. That's why we know what the initial starting lead amounts are in zircon crystals, because they literally do not form starting with lead. If Matt has any observation to the contrary, I welcome him to demonstrate that. Then he talked about this experiment in Ukraine for showing supposedly accelerated nuclear decay. I don't think that that's what that experiment shows at all. I mean, show me where it shows that at all in the experiment. I mean, first of all, they use, conditions that are very, very extreme. I think that they literally have to turn their sample into plasma. And then he's saying that these super heavy elements decay very rapidly. Well, yeah, we expect them to, right? So, most super heavy elements do decay very rapidly. I don't understand how he thinks that this is an example of accelerated nuclear decay if all the decay rates are what we would expect them to be. So we can go back to that maybe if he brings up an example of like a specific example of how this would be accelerated nuclear decay or how this would violate our expectations. But yeah, nuclear decay rates are worked out by calculating from basic principles, like from quantum mechanics, basic physics. We can calculate what the decay rates should be, and then we observe them, and they match our predictions. That's why we know that decay rates are constant. Then he brings up that supernovas are not capable of creating elements heavier than lead. Yeah, we've definitely observed that. I don't know at the time of that publication, maybe, but we've observed uranium in supernovas in spectral analysis. So no, that is not true. Supernovas and I think also like neutron star collisions can also produce super heavy elements. It's the R process. Look up the R process. You can see what it's capable of. It's pretty well established science. We know that supernovas are capable of synthesizing all the super heavy elements. He talks about the lead paradox. The lead paradox has lots of potential answers. It's not really that big of an issue. You just get sources of lead outside of your sample. It happens all the time. And, it's less so of a problem in that like scientists do have to account for it. They just have to be careful. They acknowledge that it could be a problem if there's a nearby source of lead. So they're not going to try to use that dating method if they know that there's been contaminating lead in that example. So, it's just something that scientists, whenever they want to do dating, have to take into account. And they do. Like they know about these potential issues and they avoid them because they know about them. So it's not, I don't really understand how that's an issue either. Then he said that why is most of the uranium in the crust? Well, that's because it's less dense than the material in the mantle and the core. Pretty obvious. He thinks that just because uranium has a heavier atomic weight means that it necessarily has to be more dense, but he doesn't realize that uranium is not found in an elemental state. It's found within uranium minerals. And because uranium has such a large volume relative to its mass, that it when it incorporates into these minerals, they are less dense than like the material in the mantle and core. So we would absolutely not expect uranium to be like in the super dense areas of the earth because one, it doesn't incorporate into like the kind of iron minerals that are in the core because again, it's too big. It doesn't incorporate into those crystalline structures. So it will go up to the crust. This is like perfectly in line with our expectations based on the properties of uranium. Then he talked about the ratios at the formation. The ratios of parent and daughter are the same as they are today. That statement on its face of it makes no sense. There are no consistent ratios of parent and daughter that we just find everywhere today because the ratios of parent and daughter vary all over the earth because they depend on when that sample was formed. Right. So him just saying it matches the parent and daughter ratios we observe today. We observe all kinds of parent and daughter ratios today. It just depends on the age of the sample in question. So that criticism literally made no sense to me. Maybe Matt needs to rephrase this or something, but we could talk about that more in the discussion. Donny, how am I doing for time here?
You're doing good. You just hit the 7-minute mark. So you got 4 minutes.
Okay. Well, at this point, I don't think that I've heard any substantive reason to doubt the veracity of radiometric dating at all. So I've tried to address most of the points that I remember Matt saying, and I'll just open it up to open discussion at this point so that we can actually get into a good discussion of these points, because I think I covered most of what he brought up. If he feels like I didn't, then maybe we could talk about it in the open discussion. But I'm happy to just go whatever Matt wants to bring up here, I think I've debunked most of the things that he brought up in his opening.
Absolutely. Very detailed opening arguments and responses here from Grayson and also from Matt. So we got many different points on the table for discussion. And so I think it is a great thing that we have lots of time for discussion as we move into just that, a very comprehensive discussion portion, as we want to engage all the points and engage them thoroughly. And so, Matt, we are going to hand it back to you since Grayson just ended with his response. And why don't you pick the first point that you think would be good or beneficial to engage, and then by the time we're done the discussion, we'll make sure that we've engaged every single point brought up. So Matt, go ahead.
Okay. I'll do the one that he said to reiterate then, because that makes the most sense. Because so I said the ratios and proportions that matter the most is if something is forming and it has the highest amount of parent isotope, then clearly the decay can only come from that. So if the parent isotope formed as it would have 4.5 billion years ago, then that makes sense that, well, we go, then lots of time must have passed because now we're finding ratios that don't match that. But instead, the oldest we find is what is on the Earth today, because the parent ratio, isotope ratio, matches what we're seeing today. So if you're getting, I said the potassium, and you look over and what we see today, or let's give it uranium-235, it's 0.7202% on Earth. So if we created it in a laboratory and it showed up at 3.7 enriched percent uranium-235, we go, ooh, we're going to have some explaining to do, because obviously billions of years had to have passed. But instead, when we form, it forms at the ratio that we see today on the crust of the Earth at 0.7202%. So we go, awesome, that's great news for young Earth creation, because that's the ratio that we see. And if it actually had formed in the ratios of deep time, then that's where I'm trying to come from. I hope that made sense.
I think I follow it a little bit better now. You're saying that like the uranium ratio, in terms of the ratio of all the material on Earth, the amount of that is uranium is the same that we observe in experiments where they create uranium.
Right. Yeah. There's the proportional amount, which is that we find on the Earth. And then there's the ratio amount, how much parent to daughter isotope.
Yeah.
So I can share my screen again and show you.
Again, the ratio of parent to daughter varies all over the Earth, just depending on where you're sampling the uranium and lead from.
Right. But we're going back to we're looking at the samples that have the highest ratio of parent isotope, because we want to get the age of the Earth. So we're not going to look down the line at some of the uranium that has 0.4% or something like that. We're going to look over at
the oldest ones would have the least amount of uranium.
Right, exactly. So there's only one place in the world that exists, and that would be at the Oklo lab or Oklo reactor, where accelerated nuclear decay probably happened in that region. But it's missing 1 million years.
Wait. Why do you think that the Oklo natural fission reactor shows evidence for accelerated nuclear decay?
Mostly because the reactor itself couldn't have naturally fissioned based on the shape of the reactors that are sitting over it. They're a weird shape. They're not round like a reactor would be. They're just slabs, and they have to have a certain density so they can actually create a fission reaction and then turn on, because it needs to turn on and off over billions of years. Right? The Oklo reactor was supposedly fissioned with an enrichment level of 3.7% billions of years ago, and then turned on and off as water filled back in over hundreds of thousands of years. So, but we're saying that it was a rapid thing because they couldn't have occurred based on the structures of the plates. So I make the case that lightning was the initial reaction fission that occurred, and it sped up the reaction really, really quickly. Because obviously we have to have an explanation as young Earth creationists for the Oklo reactor. We can't say that it happened over millions of years. We have to have a short time frame. So I'm claiming that accelerated nuclear decay happened there.
Yeah. Okay. So in it of itself, I don't see anything inherent about the Oklo reactor. I mean, all you're saying is that the shape is different from a man-made nuclear reactor. But I haven't heard any explanation about why the shape would preclude it, and why also none of the nuclear scientists would agree with that. I mean, like the Oklo nuclear reactor is called a natural reactor. And this was hypothesized back in the 50s before they found it. A nuclear scientist said, hey, it should be possible to have natural nuclear reactors. I think it was like 1956 or something. And he had a paper predicting that these things should be possible. And then in the 70s, we found Oklo, and we found that it was. So it seems like he predicted it based on the theory, and then we found one. I don't understand. You're saying that there is some characteristic about its shape that somehow precludes it from being that, but I haven't seen that demonstrated by any scientist.
I was saying that the shape itself would have really limited its ability to create a fission reaction in the first place. So what happens is, for natural fission to ignite in the environment, they assume that it needs a uranium-235 enrichment between 3 to 5%. That hasn't existed at any time in the present. So they said this must have happened billions of years ago, because that's the only time there could have been that enrichment level. Then they said, we don't know. It could have been active for 20,000 years to 500,000 years or a million years. They don't really know how long it was on or activated. But I came along and I was looking at it, and I found a couple papers that was showing that the reactor itself probably couldn't have naturally created the fission reaction even at that high enrichment level because of the shape of the reactor. So my answer to that would have been lightning started it. It would have, because of, go ahead.
Okay, yeah, I think I would want to see the calculations showing that it doesn't work in a purely natural means, because everything I'm aware of from the Oklo natural reactor is that it is naturally occurring, and I don't see any inconsistency in that. So if I saw the calculations that say, hey, look, with this shape, this is what you would expect, and that doesn't match reality, I'd be a little bit more convinced. But so far, I haven't seen the evidence for that. But I know that we didn't go over these points beforehand, so I'm not expecting you to bring the calculations. But just for something that would convince me, I would want to see the calculations showing why it doesn't work, rather than just hearing the claim that it doesn't work without actually getting the justification, really.
Right. Okay.
Yeah. So you want to talk about like the Ukraine experiment, or?
Yeah, you were saying that also we didn't expect uranium in the core. I thought that's what they thought was powering the core. I thought they expected uranium to be deep within the core.
No. So the majority, radioactive decay does contribute heat to the core, but the majority of the heat in the core is from the formation of the Earth. It's retained heat because the size of the Earth is large enough to where the core has retained heat that was present at its formation. So the majority of the heat from the core is from the formation of the Earth. And I'm just giving you the scientific consensus here. So the scientific consensus is not that the heat in the core is powered primarily by radioactive decay. That is not the consensus view.
Got it. Okay. Got it. Just wanted to make sure, because when they found that there was most radioactive elements on the crust of the Earth, and mostly in Australia, it seems they're pretty shocked from it. When I was reading the papers, they were like, this is unpredicted. We didn't expect that. And so the distribution from our standpoint would obviously be the global flood of Noah. The evolutionary one would be plate tectonics, I'm guessing.
I could see them being surprised that maybe it would be so rich in Australia in particular. I could see that being a surprise, but I think that would largely depend on the geological history of Australia. I mean, they are just going to have some places like that have a lot of iron or have a lot of copper, and it depends on their geological history. I don't know how a flood explains why all the uranium would be in Australia either, specifically Australia. I mean, I don't think, I haven't heard an explanation for that, but it is interesting.
I haven't heard the flood model actually explain that one either. So, but I didn't look into it. But
I'll look into it too, about why Australia is so uranium rich. I don't know offhand, but I just don't know either model really, providing. I mean, I just think it has to do with the geological history of Australia. That's all.
And you were saying that the supernovas do create uranium and these things. That's interesting, because I've been reading that they do not. So I just don't know how that would solve the lead paradox, but it would at least be able to answer some of the uranium. But
they also create lead. Like all of the elements that are higher, that are heavier than iron, are produced in supernovas.
So uranium, thorium, all the radioactive elements are.
Well, no, there are some radioactive elements that are less heavy than iron. So like
Yeah,
you can create nitrogen 14 in the cores of stars and stuff that decays into carbon 14. But the really heavy elements, the elements that are heavier than iron, are produced by the R process, which happens in supernovas, and also like really weird things like neutron star collisions and just kind of like really niche stuff. But the majority of it comes from supernovas in the current scientific consensus.
Okay. All right. So I would imagine then that we would be dating a lot of different things maybe coming from there with different dates then, right? If there was an explosion, a supernova, and it blew debris that we could test, I don't know how they would test it with instruments, but they are able to gauge like what type of elements are there. So why would the uranium be?
So we don't actually get any of the material from like distant supernovas. We just can determine what it is based on spectroscopy. So we can look at the kind of light that's emitted and know what the elemental composition is. But the actual material itself is not making it all the way to Earth. That's like a ridiculously long distance. But I do think what's really interesting, right, is that whenever we date things, like really old things, like meteorites or the oldest rocks on Earth, the oldest dates that we seem to get all seem to converge around 4.6 billion years, right? So I've heard you mention before that all these scientists are just trying to get the oldest date possible. And it seems like, you know, I mean, why not 9 billion? Why not 10 billion? You know, like why do all these dates seem to converge around 4? We find a lot of 4.5, 4.6 billion year old stuff, at least according to uranium dating, like on zircon crystals and things. We find a ton of that on meteor. Like we test a lot of meteors. They all seem to come back around 4.5, 4.6. So like, what's the explanation for that?
I would have to say that it's based on what the laboratory got, right? If the laboratory created these, the very way that we're testing these elements, and we're seeing like, let's say we gather something from the moon and we go, man, how old is the moon? Did it come from Earth or whatnot? We're going to test in the same way we would test anything on Earth. We'd go, how many daughter isotopes are there in comparison? Mm-hmm. However, the least amount is going to show us, well, that much time must have decayed. But when that laboratory comes out and they go, wow, look at this. A lot of the parent isotopes match the distance with the daughter isotopes, and it looks like that much time has passed, but it formed 3 minutes ago. Man, our assumptions were wrong. We have to now reevaluate, because that's why I said there are assumptions, but I think the most important one of all is when they formed. Kent Hovind likes to use a candle example, right? He goes, You walk into a room, you see it burning. I try to use a clock because a clock represents it better. I think there's clocks inside of clocks. They didn't expect that when it formed. When they formed the potassium, they would have never gone like, oh my gosh, look at all the other elements that formed with it. The daughter isotopes as well. That's very peculiar. To me, that was the smoking gun, because if we look at, unfortunately, they didn't have carbon, they didn't have argon. Those were the gases. Those would have been really nice to have because they could really pinpoint a date. The best I could do was the aluminum, and aluminum has a very, very short half-life, but yet we find it all over the place right when it forms, just like it is today.
So then let's talk about the initial conditions and what assumptions go along with that, because there are several, like I said, the assumptions about the initial conditions vary from technique to technique. I talked about in my opening/rebuttal, I talked about uranium and lead in zircon and how zircon crystals do not form with any appreciable amounts of lead in them. But there's also isochron dating. I'm sure you're familiar with it. Isochron dating, just for those in the audience, doesn't rely on any assumptions about the initial conditions at all. So you don't make any assumptions about what the initial conditions were like in isochron dating. And you can corroborate the dates that you get in isochron dating with those other methods, and they largely agree with each other. So the corroboration between the different methodologies is really, this what the final nail in the coffin that proves it in my eyes. So I'd be interested in hearing the response to that.
Yeah, no, I would agree that isochron should predict it, right? Because if the elements are forming and they're all ticking as clocks and they tick perfectly, we would expect a perfect clock to tell time perfectly. The only problem is of course we can use them going backwards in time, but if time doesn't exist, just like the characters in that video game that I gave a clock to, they're reversing it in their mind and they're like, well, the clock is perfect, it must work going backwards in time. Yes, it does work. You just don't have any time to go off of. It was created last week by me. So we could easily say we can go back 100 million years. But there's nothing there. It's just the clocks that we're looking at. We're using a wristwatch. We're saying, well, it works. It shows that there's time, so it must be time, but no time yet.
So is the reason that you're chalking this up to is basically accelerated nuclear decay, or did God just create the universe with those isotope ratios already present?
I think accelerated nuclear decay seems kind of more unnecessary. Sure, it could have happened because that would explain why there is lead and zircon crystals. It would explain why there's these things. But they placed them all during the flood. That's a horrible time to have placed it. Why not in the creation when God's creating the mountains and everything, like day 3? That's when you would place accelerated nuclear decay, because that's when everything is rapidly forming. Trees, mountains, not trees. The mountains are forming rapidly in the day 3. So of course you're going to find some accelerated nuclear decay probably in those. But they wanted to say, because they found them in the Grand Canyon, the rate team, that it must have happened during the flood. But you can get a lot of that from uplift as well. So
then my question would be, then how is the flood sorting these different minerals based on their isotope ratios, right? Because when we get like certain layers in like the geologic column, we see like, you know, that they are ordered according to isotopic ratios. Great question. How exactly does the flood sort these things by their, like, if for example, just real quick, like if you were to give me a different ratio of isotopes, you say like this sample has this ratio of uranium, this ratio of lead, I'd be able to tell you based on that, well, you would expect to find these fossils above it, these fossils below it, these isotope ratios above it, and these ones below it. And like you would find that that's consistent. So like, how does a flood explain that?
I would say, Donny, share my screen. I made one picture actually just for that. Right here. They're proportional based on their weight and their atomic weight. So your uranium weighs the most. It's going, if you had a jar and you shook it up and it's got all of these different radioactive elements mixed in with non-radioactive, you're going to get a settlement. And the settling of the layers that we believe all formed during the flood would obviously settle in the ratios and proportions. So we get potassium in the upper one because it's the lightest, and that's what we find. And it also just happens that it dates the youngest, and uranium dates the oldest, but it also just manages and happens to be the heaviest, so it sinks.
Okay, so what about my point in my opening that like just listing the atomic weights does not actually tell us the true density of these materials? Because you're not finding uranium in its elemental form in nature. You're finding uranium minerals. That is uranium with a bunch of other different atoms. So the actual density of uranium minerals is not more dense than a lot of this stuff. Like if it was just being sorted based on density, we would not expect to find like, I mean, it's not even really that we find uranium on the bottom. I mean, you can find zircon crystals at like nearly every layer. So it's not like these things are sorted in that way either. So I just disagree with the entire premise there. But I want to specifically just get to this point that uranium minerals are not that dense.
But they do have an atomic weight. So there would be a settlement based on when the formation of these things are happening. So you get sandstone. You get sedimentary layers. Okay. Sedimentary layers are formed from the flood, right? So that's why they're there.
What is more dense, hydrogen gas or helium gas?
Ooh, they're both gases. They're both extremely light.
Yeah. But like, see, helium gas, okay, so hydrogen gas has to be H2. So it's not like they're just individual hydrogen atoms going around. They're formed like they have to be together. So their atomic weight in naturally occurring is multiplied by 2. So this is a similar example with uranium, because if you're just saying the atomic weights are sorted like this, you're not looking at the actual picture you need to be looking at, which is how is uranium actually occurring in nature and how dense are those materials? Because materials that actually contain uranium usually contain very, very small amounts of uranium, and that uranium is bound together in structures that are less dense than a lot of other rocks that are found above it and below it.
Right, but we're only dating the rock, the layers, based on the radioactive elements. We're not picking up and dating them based on anything else.
But those radioactive elements are not like they're found within mineral structures. They're not just isolated by themselves. Yeah. They're within a larger structure. So what you need to be looking at is the density of uranium minerals, not just the atomic weight of uranium. You have to think, how does uranium actually occur in nature, and how dense are the minerals that it occurs in? That's the real question.
So you don't think the ratio would be indicative based on their weight at all? It should be based on the rocks that they're found in only, right? So that's why you're saying that it doesn't make any sense from a global flood standpoint.
Yeah, I'm saying like the idea that uranium has the highest atomic weight, so it should be at the bottom of the geologic record, doesn't hold water, because uranium is not found by itself in nature. It's found as part of bigger structures that are not that dense.
Right, but they're still all in the upper crust of the earth. That's the interesting thing.
Yes.
All of these are just in a few layers at the very top.
Exactly, because they're not that dense. If they were more dense, they would be down in the mantle and the core. But they're not that dense. That's why they're in the crust.
Right, but we explained that that's how they got there, from the flood. Otherwise, they would have, if deep time was true, they would have sunk slowly because they are so heavy. They would have.
No, they would not sink because they're not that dense. The mantle is more dense. That the mantle is more dense than uranium minerals on the crust, so they would not sink.
Well, they would be pulled down through convection over time, because they would eventually be. Yeah, you get the earth. Where are they? They're on the surface of the ocean, right? I'm sorry, at the bottom of the ocean. They'd be going through convection, pulled down into the core.
So if you have uranium in minerals that like subducts and gets pulled down into the mantle, what happens? You melt those uranium minerals, and then you get little like free floating uranium or whatever, but it doesn't incorporate into the material in the mantle. The actual size of the uranium atoms has too large of a volume for it to fit in such a densely packed material like is found in the mantle. So if it's not incorporating and it's not as dense as the surrounding really densely packed material, it's going to go back up to the crust. So like, yeah, it makes sense why the uranium's in the crust, because of its properties of density and volume.
Interesting. It seems so different than what the scientists they seem so shocked by it, but you sound like you're so you knew it already. That's amazing. That's good. I mean,
the density of uranium minerals, I mean, it's pretty empirical. You can look at what the densities are. It makes sense. So do you want to go to, maybe we talked about supernovas. We haven't talked about the Ukraine experiment yet.
Okay.
Yeah. So to my knowledge, they were doing that, like they had to form a plasma, right? I mean, they had to make this stuff into a plasma state by adding like a ton of heat and pressure, right? That's how they were able to get this experiment to work.
Right. They use Z-pinch, they cold fusion, they zap a piece of pure copper, and the copper explodes, and it now has all those new elements around it.
Well, I don't think they're doing cold fusion, but yes, they are using like a Z-pinch, which is where you have a really strong electromagnetic field that takes like a column of plasma and pinches it together to make it really, really dense. So that's a Z-pinch, and you could probably get some like faster decay rates with a Z-pinch, because you literally have stripped it of all of its electrons. You've turned it into a super hot, dense plasma. But like, how can that possibly happen on Earth? I mean, you're just going to make the entire Earth into a hot, dense plasma? I mean, like, you talk about the heat problem. I mean, you've literally just turned the Earth into a tiny sun.
Well, remember that's what they're invoking during the flood. I'm just saying that this is what happened at the very beginning of the creation of the Earth, right? It could have happened 5 minutes ago for all we matter, because but I'm just saying that the creation event is when these would have happened, and that's, I think, why we're finding them in the ratios that we are. Just a few thousand years. It could have been 10,000. We don't know. As young Earth creationists, it's a shame that I was really hoping to get a really nice view of exactly when it could happen. Unfortunately, the best I can pull out is 730,000 years. Not even 1 million years old for the Earth, because of those ratios, right? The proportions between them. So therefore, when did that happen? Maybe early on, when they were actually being formed. But that doesn't make a very old Earth. So when did it happen? Not that long ago. How? I don't know. But God could have formed the Earth in that very principle from the very beginning. Creationists don't believe in the process, or I'm sorry, in the radioactive elements. A lot of them, like because of Walt Brown, right? He said no, they're damaging, so God must have not created them. Well, now we have evidence that lightning kind of can do a Z-pinch, but like you said, they need to be in a plasma state. Well, that is pretty hot to liquefy uranium. I think it's like 2,000 something degrees, but to turn it into plasma, it's even hotter. Yep. But it only needs to happen once, and it needs to happen in a certain region, and then that's what starts the formation of them. now, and in the amount that needs to cover the amount that's on Earth, a pretty big blast of it. But that's what's interesting. We don't find that being created all over the place at different times, because otherwise we would find lots of those events on Earth had happened over eons of time and all different kinds of radiometric dates. But it's pretty consistent that must have happened at one time.
We're kind of going in circles here, because initially when you brought up, well, if all of this radioactive decay happened by like a miracle during the week that God created the Earth or whatever, like before life happened, if all that happened and all that heat was released and all that radiation happened then it still doesn't explain the order of these radiometric isotopes that we find. I mean, for example, in the oil and gas industry, one of the, like, they have multiple methods to like find and categorize oil deposits, but one of them is radiometric dating. They know that if they find like a certain ratio of parent and daughter isotope, then they know that oil is highly likely to be nearby that. So I don't see any physics or any chemistry or any process that could possibly explain that other than an old age of the Earth.
Well, I actually made a video showing that young Earth creationists actually predicted that, not based on the age or the time, but the actual layer, that it's going to be found that it was a rapid C4 spreading, and that we're going to find that that's when that was created. So yes, the radiometric dates that are attributed to those layers would work, because why not, right? That's when it happened, but not the times that they're giving, just the layers itself. Like, that's what matters the most. We're saying catastrophism, and uniformitarianism is just going by the dates. We ignore the dates and just say, just look at the layers. We'll find evidence for this and this in it. And that's what was true. That was a catastrophic plate tectonics one. I have a short 4-minute video showing that prediction, that way ahead, when they said that these layers are going to show the rapid plate movement, and eventually the bottom of the ocean that's there now wasn't the same as it was before. That's why it moves so much more rapidly.
Okay, so I'm hearing what you're saying about like catastrophism and plate tectonics moving very, very quickly, but I don't see how that explains how certain isotopic ratios are statistically very likely to be near oil deposits. But really quick, on the topic that you just brought up with C4 spreading being really quick, why would it be then that when we date different areas of like the mid-Atlantic ridge where there's like C4 spreading, right?
Yeah.
When we use radiometric dating, like to get the dates for the different sections of it, right?
Uh-huh.
And then we do use a totally different method to try to cross corroborate that, right? We say, look, all our data today shows that the tectonic plates move at this certain rate. Like, it's like, I think it's the same rate that your fingernail grows. So if we extrapolate that back, right, then where would that position be? And it's right at the mid-Atlantic ridge. Like, we can also use paleomagnetic data, where we have, the actual data about the Earth's magnetic field being imprinted in the iron deposits in those rocks. And we can date based on that geomagnetic data as well. So there's multiple sources, and they all give the same date. So that sounds like you would have to think that that's just a total coincidence.
Good question. Let me screen share, Donny. He probably went to sleep.
He might have had a bathroom break or a coffee break or something.
There we go. So the interesting thing about potassium to argon ratio dating is that we found from experiments that the deeper the lava goes and the colder the temperature, both of those factors completely change the potassium to argon ratio. And the deeper it goes and the colder it gets, you're going to get a different answer to those dates, and they rapidly increase in time. This shows right here, and they've even made the direct statement. I have it around here some way. Use caution, because when we're dating these things, they don't really match up. So this study right here shows you why we get such late dates, and why they show they're so old.
So no, that your actual logic there and the logic of these papers makes sense. That's why potassium argon or argon dating are not they're not the radiometric dating method that we use to date the mid-Atlantic ridge or C4 spreading. We use other radiometric dating methods that are not impacted by this phenomena of being like under the ocean and highly pressurized. We use other metrics. That's why we don't use just argon dating for that. And then even if that's the case, right? Even if we only used potassium argon or argon argon, why would it match the data of just like extrapolating back the current rate of the tectonic plate movement? I mean, that would still, even if you're saying that these are not accurate radiometric measurements, they still match with what we observed just going back with like extrapolating back with the movement of tectonic plates. So that still has to just be a massive coincidence in your worldview.
Well, that's of course if you're assuming when those plates were moving, right? The oldest dates you can actually get with the seafloor spreading is very, very young. You don't get billions of years at all. You get 180 million years. It's very, very young for seafloor spreading, and we're saying that it happened rapidly. And then you go to test it, and you see that it actually doesn't work so good. They actually should have used potassium to potassium or argon argon maybe, but not potassium to argon because of those discrepancies that they discovered. So you said, why don't they? Well, they combine it with another thing, which is looking at magnetic reversals. We say those happen rapidly during the flood. You said, no, they happen slowly over time. So we end up arguing because our views are different. We say catastrophism. You say no. So that's why it's so hard to compromise with one another, because our goggles are just different. That's why. Okay, you go, I believe my evidence is better, and I say no, I believe mine is.
So if you just like, I don't know if you're just rejecting this and you don't agree that the methods match, but like even if we don't think about pole reversals, right? We just look, hey, the continents are moving this many centimeters per year. So if we stand here, the radiometric date that we get from this sample right here says it should be this old. So if we extrapolate that movement and say, well, if it was moving X centimeters per year, how long would it take to go, where would it be if we extract back from this radiometric date? And then we extract that back and find, hey, it's right in the middle of the mid-Atlantic ridge. And that logic follows all over the mid-Atlantic ridge. If you want to go way, way out and do it, or you want to go right next to the mid-Atlantic ridge and do it, I mean, you're going to match the radiometric date that you get is going to match the extrapolation from just the speed of that we observe today that these plates move at. So
I just showed you that the dates don't really match good. That's why they said that's why they're coming up with these answers saying these aren't good. These all came from looking at the mid-Atlantic ridge seafloor splitting. They're saying it's faster than it should be because they're decaying rapidly. So if they're decaying rapidly, you can't extrapolate back to the actual mid-Atlantic ridge because they're saying you can't use the radiometric dates. They're admitting that in the very study itself. They said don't trust them. Like caution, right here, the last sentence. Caution is urged when applying dates to the deep floor basalts and the seafloor spreading. They admit you can't use them. So we say it's specific. Okay.
That is being specific, just so we're clear here. That paper is specific to the issue we're talking about, underwater argon, and potassium argon dating, right?
Right. That's all they use.
So that would not apply to other radiometric dating methods that we use to date the seafloor spreading, right?
But they don't.
It only applies to argon.
They do use. That's what's interesting. I look for other methods. They don't use any. That's the interesting part. There's no uranium down there for them to use them. Thorium to uranium, there's like none there for them to use. I don't know why, but it's not there. That's why they use potassium to argon, because the mid-Atlantic ridge is a giant volcano. So what's coming out of it? Brand new seafloor. So they go to it and they go, well, best to test the argon. Well, it would be great if it was on the surface, but it's not. It's under the ocean. And the more it flows down that gigantic mid-Atlantic ridge, the faster it starts dating radiometrically. That's why I said I agree with radiometric dates for the most part, but there's some discrepancies. I made this little clock right here. I could drop it. I could throw it in water. It might slow down. It might break. There's some problems overall, but overall, I like them. That's why I think the experiment's so cool, that it literally shows the Earth can't be that old.
Which experiment are you talking about shows that? This one here you're showing?
No seafloor spreading. I was just showing you that they use potassium argon, and that it shows a disproportionate age as it goes on. Matter of fact, this study right here showed that helium and argon which was amazing because it uses argon, was a prediction by Dr. Humphrey on argon dates that would be found in 2011. In 2013, on the bottom study, he actually confirmed those, or somebody else was able to confirm his predictions on the seafloor with that one. So that's amazing because that comes from our camp. So
I definitely am highly skeptical of those claims, but only because I am familiar with Dr. Humphrey's diffusion model for helium, and I know it is not correct. I know like what he has calculated for the diffusion rates of helium is not accurate. So I know that for a fact. So I haven't looked at this specific diffusion for argon that he's worked out, but I'm highly suspect of it because I already know of Dr. Humphrey's work with helium. And I've seen the calculations to demonstrate why it's not correct. So
did he use was his based on a solid temperature?
So
tell the audience what it is real quick, because I think he based it on the where the helium diffusion was based on a solid temperature rate, right? You got 6,000 years plus or minus 2,000.
There are a lot of issues with Dr. Humphrey's math, but the biggest one in my mind is that there are actually two states that helium gas can exist in within those minerals. There's a loosely bound state where it is more free to diffuse, and then there's a tightly bound state. And Dr. Humphrey ignores the existence of the tightly bound state. So his calculations only are for the loosely bound state when we know that there are those two different states for helium to exist within those minerals. So he's ignoring evidence. And I've seen a very in-depth breakdown of like all of the false premises that his math has in its assumptions. So that's for helium. I don't want to make any comments about his argon calculations, but I am highly suspect. But I will look into that to see if, he made this prediction and it matched with reality. That interests me. So I will look into it. But at the moment, I'm not aware of that data.
Okay, no problem. Yeah, we don't want to go off on other things because, I don't want to go down a rabbit hole too quick.
So it seems like we've kind of covered a lot of the topics that were brought up in the openings. Do you think that we've left anything on the table so far, or?
Yeah, I don't know. I haven't been watching the comment section at all, so I don't know what people are saying or wanting us where they want us to go. But I think we did cover the vast majority.
The only thing this analogy of clocks, right?
Okay.
Like the analogy sort of breaks down for me. Because unlike a clock, right? I mean, you have these initial conditions where like a zircon crystal does not form with lead in it. It's not like you can say clocks cannot be made starting at 6 p.m. Like, yeah, you can make a clock starting at any starting time, but
right.
You cannot make a zircon crystal with any amount of uranium and lead ratio. It has to be very, very, very small amounts of lead. You can't, like a zircon crystal just will not form with all that lead. So there are like constraints in radiometric dating methods that are nowhere in the analogy of the clock. Like I agree that they're at a constant rate, much like the ticking of a clock, but it would be like, if you could only, if clocks could only be made starting at midnight, and then once the clock reaches 6 p.m., it stops working, because that's like the analogy of all daughter element and no more parent, right? So the clock analogy doesn't really work for all the aspects of radiometric dating. It only works for just the constant rate, like analogy part of it.
Okay, I got what you're saying. So your problem isn't really that they form in the ratios that they are today. You're saying that, okay, so they can form in the ratios, but it doesn't answer why zircon crystals have it, because they could. So what? It formed 6,000 years ago. There's no possible way zircon crystals would have it in there over such a short period of time. Like
if you form a zircon today in a lab, or you go and look at one that just formed in nature, you're not going to find one that has appreciable amounts of lead in it. And that's why we know that, like, if you find a zircon crystal with a bunch of lead in it, that's why we know the lead is from the decay of the uranium that was originally present, because there is no observational or theoretical or any kind of explanation for how a zircon crystal can form with that much lead in it to start with. Like if you can demonstrate that, if you can say, hey, this guy in his lab under these conditions, he formed zircon crystals with tons of lead in the initial crystals, if you could show me that, I'd be happy to look at that. But to my knowledge, that has never been demonstrated by anybody. Every time they form zircon crystals, there's like they just don't form with lead already in them.
No problem. We can answer that again by going back to the study and finding that the daughter isotopes that form, they already form with massive amounts of these daughter isotopes that are right next to lead, a high amount. So if now they rapidly decay and they're forming into lead, that means that the zircon that has lead in it didn't have to already come from the uranium and the thorium and down the entire decay chain over billions of years. It could have come from a very short period of time, because a lot of these have just a few minutes of worth of decay. That's why they're forming them, right? That's why they're making money off of it. It's a private organization, right? They create all these radioactive, fast burning isotopes, the daughter ones, and they're rapidly decaying. So they bottle them up and sell it as fast as they can. They isolate them and put them in, use them for medical things. So how would that get in? How would they form into lead, or how would so much lead get in there? Easy. All that needs to happen is the daughter elements were just in high amounts and they were rapidly decaying once they got inside the zircon.
So you're saying that there were elements like that are intermediate in the decay chain from uranium to lead, and
Yes.
those intermediate elements were formed like in this experiment in zircon crystals, or is this experiment just how do they form these parent and daughter like elements in this experiment you're talking about?
So when the plasma hits the piece of pure copper and it produces, let's say, potassium, it doesn't just create like potassium 40. It actually doesn't really create much potassium 40. It creates tons of potassium 39, little bits of 40, a little bit more of 41. It's creating all the different ratios. But then when you start like getting into the titanium or the iodine 131, it creates massive portions of it, but they have a very fast half-life. So if it forms those in very high proportions, then you're going to get lots of lead really, really quickly. Because
so you're talking about like a nuclear reactor here? You're talking about plasma? Like, I mean, we see zircon crystals form in nature. There's no plasma involved.
Right. No, the zircon crystals are already everywhere. Let's just put them in the ground right now, and they start forming. But there's already some radioactive elements that are formed right at the same time. Like all these things are forming in the creation week, right?
But we don't see that in zircon crystals forming today. It's like if your argument would have more credibility if you could say, look, they found these zircon crystals like formed in this lava or metamorphic area that was recently formed, like today, which zircon crystals are forming today still. And if we went in them and we found, hey, look, these have tons of radioactive elements in them, intermediate in the uranium decay chain, and look, they're very, very quickly forming a lot of lead in these recent zircon crystals. The thing is that doesn't exist. At least not to my knowledge. If you have a demonstration, an observation, or a study of that, be my guest. I would love to see it. But I don't think that's ever been observed. So I get what you're proposing, but I just don't think that there's evidence to support it.
Well, that's the thing, too, is we don't see new radioactive elements being created today just randomly out in nature, right? We don't see these new the formation that they're doing at the laboratory when they're creating these. We don't see that happening out in nature that I'm aware of.
But C14 is formed naturally in the upper atmosphere.
Oh, yeah. Carbon is good stuff. But unfortunately, they don't deal with gases. They only deal with the physical elemental forms. They might work with some argon gas or some carbon, but not much. I don't read too much of their experiments with that. It was very, I don't see too much.
Like C14 is radioactive, right? C14 dating, it decays into like C12. And that C14 is formed like naturally in the upper atmosphere from like radiation. Radiation hits it from the sun and like forms radioactive C14. So like radioactive elements can be produced today. But I think that's a little bit off besides the point, I guess. I mean, I don't know.
Yeah, I was just saying that if we're expecting to find a brand new piece of zircon that forms, we wouldn't be able to find a lot of these brand new high ratios that we're getting from the laboratory because we're not seeing them form in nature today. That's what I meant. That would be a really hard thing to be able to prove on our side.
Yeah, zircon crystals. They are forming today. You can go and look at some recently formed zircon crystals and look at what ratio of uranium to lead that they have. And there you go. It's not like this big, huge assumption that has no empirical base. We know how zircon crystals form, and we know what composition they form with. So there's not a whole lot of lead in recently formed zircon crystals.
Right. That's because, like I said, if they had formed in creation week when all the other radioactive elements were forming, they would have had the capacity to absorb tons of these daughter isotopes, which would have rapidly decayed into the lead. So it would have given the appearance of loss of age. That's what I'm trying to say.
So then all of those zircon crystals should give the exact same age whenever we do a radiometric dating. But you can find zircon crystals of all different kinds of ratios and ages.
Right. That's because just like on the surface of the Earth today, it's all over the place. Because
but the thing is that they're locally consistent. Like, it's not like if you take one sample, you're going to find these zircon crystals of like all these crazy different ages. I mean, like, and the really interesting thing is when you look at the same formation, right? And you look at the samples at the top of the formation versus the samples at the bottom, you'll see that they have slightly different radiometric isotope ratios. And the ones on the top have more parent and less daughter than the ones on the bottom. And it's the same formation. So, like, clearly that shows that the formation did not form all at the same time.
I think I follow.
So, yeah, if you have the same formation and the top of the formation is dating younger than the bottom of the same formation, like they have different ratios of parent and daughter in the same exact formation, that shows that the bottom of the formation was formed before the top by a significant amount of time.
I see what you're saying, but then again, it goes back to you just witnessed zircon crystals form. Okay, so yeah, they are going to form on the above the next one, right? How do these form? Are they formed in the deeper layers and come up, or do they form on uplifts or earthquake faults? Like, how are these zircon crystals being formed?
So I'm pretty sure you can form zircon crystals both from like igneous sources, so from like cooling magma, but you can also form them like metamorphically. So I think that there are different circumstances that form zircon crystals, but that's about the extent of my knowledge to like the actual like area where they're formed. I think that there's just multiple areas. Like, it's either there's igneous sources of zircons and there's metamorphic sources of zircons.
Okay. All right, so I'll have to answer that one. Not right now. I mean, I'll have to give you an answer because it's a debate. Got to be able to answer everything. So,
gentlemen, let me jump in real quick. Can we now engage specifically the heat and radiation problem associated with the flood and also dating methods in general? And so, Grayson, if you wanted to touch on that, and then we'll get Matt to respond. We can go back and forth on it. Matt, you can specify whether or not you believe the model that you're proposing tonight has a heat and radiation problem, because we do have questions in the audience on that topic. And so I figured it'd be good to discuss that since it is a hot topic. Grayson, go ahead.
So the issue specifically as it regards radiometric dating is that if you had all this accelerated decay, like in a small amount of time, right? There's, in the consensus view, there's like 4.5 billion years worth of radioactive decay. And in the creation view, that would be condensed down to just, I think Matt said 1 week, or, within 6,000 years or so. If you're going to have that much radioactive decay happen in that small amount of a time frame, every time something decays, right? One atom of uranium decays to the next thing down the chain, it releases heat. So if you have all of this radioactive decay happening in a very small amount of time, it's going to release a tremendous, tremendous amount of heat. So I think Matt is just going to say that all that happened in the first few days of creation when there was no life and all this heat was released, but it was no problem. I think that's where he's going with it, but we'll see.
Okay. Let me screen share again. Sorry. I like screen sharing. I don't know why. Okay, there we go. Okay. You are looking at Eugene Chaffin. He was brought on the rate team right over here on the right to help do the mathematical calculations based on accelerated nuclear decay. The critics actually wrote a website about him, and he's on American Loon Encyclopedia, and they actually like him. If you read right here, they said he's somewhat exceptional among creationists, since he actually seems to be honestly committed into doing what he thinks is science. What he did is he ran a mathematical calculations, and he said anytime you're going to be getting an accelerated nuclear decay, it's based on what's called well depth. And if you get a well depth deep enough, you can accelerate the nuclear decay. But the problem with that actually comes into the fact that once you get to a certain point, it can only oscillate back and forth a certain amount of time, and then you run into a wall. He said that oscillation is only about 10 times, and he's actually the one that discovered that the accelerated nuclear decay is a complete disaster, and said that you cannot actually get the accelerated nuclear decay on the catastrophic plate tectonics without a miracle. So he actually debunked it. He did really good math, and I think that accelerated nuclear decay is a rescue device, and for the most part, or it has to actually match the mathematical proportions that Eugene came up with. And he actually showed that you can get accelerated nuclear decay, but it has to fall within the ratios of reason. And they went outside of that, so they relied upon a miracle. I don't want to do that, so I like the Proton 21 laboratories, which shows that when they were created, they give the appearance of age. And that makes more sense than me than saying God just accelerated the bejesus out of the ground, and and you're just left with, okay, I guess. And then the math actually goes against that. So what I like is that we have some evidence of rapid movement of the seafloor. We have cold plates still subducted next to the Earth's core, which is extremely hot. That shouldn't be there. So these things show us that there could have been some accelerated nuclear decay, but I'm sorry, it couldn't have been billions of years. It would have melted the Earth, especially during the flood. So I'm against that. If you're going to account for any accelerated nuclear decay, you could probably do so in the creation week, like I would, probably on day 3. And, maybe over the process of that day, you've got a couple million years that you can get out of it. You can't get billions. So there's no reason to invoke it anymore. We have the observational studies that they're created. There's no reason to accelerate billions of years of decay anymore. That's why I like these experiments. They're observational. You can go repeat them, and you can look at them and go, oh, look, they're in the same ratio. That to me makes the most sense. There's no reason to invoke accelerated nuclear decay anymore to me. You can at certain places, but to get billions of years, like he said, with acceleration comes heat. With heat comes side effects. So you can get some, but you can't get billions.
So my only question with this so far is because the rate projects took like 8 years working all this stuff out. Why didn't they conclude that God just made in the first creation week, he just made all of these radioactive isotope ratios the way that they are today? So
great question. Yeah. They actually wrote about that in one of their papers, and let me show you what they changed their mind to for briefly. Share screen for me real quick. This actually became one of the things that they said in this book right here. They said, I propose that 4.5 billion years worth of nuclear decay at present rates unfolded in the Earth at the end of day 3. So they made their heat problem even worse because they condensed not just 1 to 2 billion years during the flood. They condensed 4.5 billion in one day at the end of the day. So they actually had that as their concept, and now they got rid of it. So that's a good question. They tried to say like maybe the proportions and ratios were different, but then they had to change their mind because they're still under the mindset that like, oh well, we still have to explain why we have so much helium in the rocks. Well, to get that much helium, they had to say that much radioactive decay sped up and needed to be produced in that ratio. They never considered the fact that, wait, maybe they were produced at that rate. You know?
That sounds, I don't know, hard for me to believe. But I mean, what this sounds like to me is, when you say, look, the light from like stars that are millions of light years away has reached us. So it was traveling for millions of years. And then I will hear a creationist say, well, the light was created already en route or something to that effect. That's what this sounds like to me, is you're saying, look, we have all of these, radioactive parent and daughter isotope ratios that are in an order in the geological column. And you can't explain that with accelerated nuclear decay. So the explanation just becomes, well, God just made it that way. Right? I mean, tell me if what you're saying is substantially different from that, but that's my understanding of what you're saying.
Not necessarily God even on this one, because what Brown was saying, that no radiometric decay would have been made by God, but we have an experiment doing it, so we can just invoke natural processes did it at that time. So natural processes could have made the radioactive elements, because I don't think we need to invoke that God did it if they're doing it in the Proton 21 laboratories. You know what I mean? It's like, well, we say God did it exactly as they did in a laboratory. Well, we don't need to invoke God for this because it's done in the laboratory. So I don't have to invoke that God did it. I just mean that, like, you know, if Adam was created and then you go, I don't understand why God would have made all the different, you know, trees looking old. Well, they had to, or else he couldn't eat. They had to be able to produce fruit, and most fruit trees don't even produce fruit for 15 years. So creation could have been accelerated. And if it was accelerated, then that it just becomes a little harder to prove. But again, that
to me, that just sounds like evoking like supernatural miracles, right? I mean, I like, you're saying that this is a natural process because we've seen in a lab, they take plasma and then they find that it creates isotopes with like ratios that you're saying are the same that we see on Earth. Right. I've already said that the isotopic ratios that we see on Earth are totally variable. Like, there is no one ratio that we see on Earth, but like between parents and daughters. But I don't know. I would just want to see, maybe I need to go and take a better look at this experiment that you're citing, because I really want to know what exactly they were producing at that lab. But to my mind, that just says basically you're saying that the Earth was formed out of plasma, is what I'm hearing. Because if these experiments have to take hot plasma and that's how they're getting these isotope ratios, then it would have to, if you're saying that that's the mechanism that's responsible, that's not just some supernatural miracle, then we would need a way for that mechanism to happen on the early Earth, which, I mean, I don't know. I don't know about scripture. That doesn't necessarily sound scriptural to me in terms of the order of Genesis, but I'm not a big scripture guy, so I'm not going to make that argument. It just is, it's hard for me to visualize what exactly you're saying, how that process is working, as taking hot plasma and then creating all of the radioactive isotopic ratios that we see on Earth that are like ordered into the layers. Like, that is a logical bridge that I'm not really crossing. I'm not getting the whole connection there.
I see. Okay. Well, the order is entirely different. I was mostly focusing on the ratios because we're talking about the dating of the Earth, the age. So the ratios on how they're proportioned would come down to me, the global flood, and you through slow, gradual tectonics. So when you go and you look at these studies, make sure to go look at the first one that I mentioned, was about iron ratios, because only one of those isotopes is really, really radiogenic. But what you'll get is the ratios that exist in the percentage that we find them on Earth. So that's what's unique. So if it formed and it's in the same ratio, then you would say, well, you know, iron comes from meteors and meteor bombardment made the Earth. Well,
wait. That's not what I would say. I would say that the iron came from stars,
right,
which is plasma. So it makes sense that if we had an experiment with plasma, that it would create those
same ratios.
Yes,
right.
That's what I would say, because most of the elements ultimately were produced in stars, which are plasma.
Right. But remember, Earth has been hit and was created also from meteors bombardment over time, over millions of years. So the ratios would be very different than immediately being created right now, you know, in a laboratory. Don't you think
the ratios on that meteor would be the same, right? Because the material that made up the Earth is the same as the material that made up those meteors. It's like this is this general scientific consensus view. It was one accretion disk, which is the same kind of ratios of all the same materials. It's all from the same origin. So the accretion disk formed into all the different planets and meteors. So it would make sense that all the planets and meteors would have similar ratios of these different elements. It would only just vary depending on, you know, like your specific location on Earth. But overall, it would make sense if all the ratios are very similar. That's why when we radiometrically date meteors, most often what we get is all 4.6 billion years old when we do like a uranium dating.
Except for when you were to look at the iron ratio of those, why would there be the exact same ratio of iron 54, which is a radioactive isotope in the exact same ratio, again, from the experiment? Now, that would
Because
be
they all
interesting.
come from the same source, which was plasma.
Yeah, but it would have rapidly decayed away over that amount of time, because the decay rate of iron 54 is, I don't know off the top of my head. Iron decay, half-life.
I mean, I don't know about iron decay off the top of my head either. So, I mean, I'm not.
Yeah, it's hard when you're doing. Oh, whoops! I typed it in wrong. Half-life of iron 54.
How do, if I could toss a question in there, gentlemen, if you don't mind, how do both models, so specifically the model that you're proposing for tonight's debate, Matt, and then also your specific position, Grayson, how do your respective models view or account for radio halos? Is accelerated decay necessary for radio halos? Because, Matt, it sounds like you're saying that there was very little to no accelerated decay at the flood. Other young Earth creationists might say radio halos are evidence for accelerated decay. And so let's kind of engage that a little bit. Grayson, if you want to start, or Matt, it's up to you guys.
I would say that they were mildly accelerated from the very beginning of creation. If there was any during the flood, I'm okay with it. But then again, we're talking millions of years probably, because that would generate a normal amount of heat that would explain why all of the aquatic life would have died, because we have that genetic evidence of the CO1 gene showing that the whole thing on Earth was a genetic bottleneck at the same time, including sardines and anchovies. So that means all fish were dying at the same time land life was. So therefore, I would have to say, yeah, the oceans definitely heated. But did they heat from convection heat only, or was there some type of accelerated nuclear decay also killing life? That's speculation. But for the radio halos, they could have easily come from the early on of creation. You get to the point where you're accelerating nuclear decay too much during the global flood, then you're also melting granite. And granite, when it reforms, comes back as rhyolite. And rhyolite can never turn back into granite. And the fact is the basement rock is still granite, so it couldn't have gotten that hot to melt the granite. So that would be my answer.
Yeah, okay. So there was a lot there. Just really quick to just.
I think you're answering them anyway. You don't have to answer me.
Yeah. Well, just going in order, I don't see how you're saying that the ocean's heated and that's what caused a big die-off in life. But like, there's no consistency with like when we look at extinct species versus the species that are alive today. It doesn't make sense how you would have like ancient species of sharks that died out, but modern species of sharks survived if they were both experiencing the same like super hot ocean. Or like there's like whales live today. I mean, like, doesn't make sense how a whale would survive like a super hot ocean if other large like aquatic creatures of the past died out, or like really small aquatic creatures died out, like trilobites or like small species of extinct fish. But like for everything that's alive today, we can find stuff that lived in similar environments, have similar body sizes, similar like eco zones, and they died out, but there are modern species that survive. So it just doesn't make sense how you can have heating of the ocean that selects for kills off all the extinct species and doesn't kill off all the species we have today. I don't really get that, but that's a little bit off topic to Donnie's question about the radio halos. So most of the time I hear this talked about polonium halos, but there's a lot of different type of radio halos. But the really curious thing I think about these for the creationists to explain is that these are only found in secondary granites, not primary granites. So primary granites are found, like that's when you have like a cooling of magma that's formed these granites. You don't ever find those kind of halos in primary granite. You only find them in secondary granite, which has undergone like a transformation due to like, you know, there's a variety of geological process that can make secondary granite. But the key thing is that secondary granite, like when you have primary granites forming, that's a closed system. Nothing interferes with any of the uranium that's like present within primary granite. It's a closed system. But when you have a secondary granite, that system was opened to outside variables in the formation of secondary granites. It's cracked open. It's exposed to outside like sources, which is where you get like these polonium halos forming, because you have like intrusion of water and polonium into the granites, which like diffuse through the granites and form these polonium halos. So there's something that I would want to, that the distinction between primary granites and secondary granites, and why we find polonium halos in one but not the other, is something that I think any young Earth creation model would have to explain, if all these granites really are that young and these polonium halos are supposedly evidence of like how quickly they formed or whatever. So that's how I'd answer that.
Grayson, thank you very much. Matt, we'll throw it back to you. Feel free to respond to Grayson's original points. And then if there's anything there you'd like to respond to as well, and we'll kind of engage that for a little bit. Go ahead.
Sure. Wow. Well, it was about the oceans killing off lots of different life forms and then some making it. Well, we have different aquatic zones. Even today, we have the ocean where there's a cutoff, and you can even see fresh water kind of floating on top of the ocean water, right? Saltier water. So there could be different zones, different areas where it would have been heated up much more at convection zones than it would have been farther away from a convection zone. And we do have some species that live. They're called living fossils, and of course they change. It's been 5,000 years since the flood, so we would expect that, because we believe in rapid speciation in the young Earth creation model. So we're fine with some living. I think that God doesn't even consider aquatic life. I honestly, because we look at life and go, oh, a piece of bacteria, that's life. That's not life to God. It doesn't have the nefesh, the ruach. It doesn't have those qualities, because God's looking at spiritual life. That's why the ocean isn't even going to be in the next world. He's not resurrecting goldfish and guppies. They're not even a life form to him. So he's not making sure that every aquatic species survived the flood or some died. They're not even living to him. It's like a plant. So to me, it's like, yeah, most died. 90% of the fossil record is aquatic species that are completely dead, because the flood was a aquatic environment that got destroyed first and foremost, right? So yeah, we would expect that most of the aquatic species were dead. But some made it. Obviously, the oceans are pretty full now. So I would have to say that the genetic evidence does show, though, that there was a genetic reset in their mitochondria, which is how we know that there was a global bottleneck. So obviously, they all did die, and there was a genetic bottleneck in the oceans as on land. That's what that CO1 gene of the 2018 Rockefeller University study showed. So that's why I brought that up. So how many died? Probably the vast majority, because theirs was reset, kind of like whaling. If you go back and look when they were doing whaling, they killed the whales off almost to complete extinction. Well, they almost had a bottleneck, so it looks like their mitochondria was reset. There was only a few left. Same thing with the Mouflon sheep on the Mouflon Islands. They dropped only 2 of them off. Boom, they exploded to 700 pretty quick, even through inbreeding. They did just fine because of the founder effect. And yet, boom, mitochondria reset. You can see it right on the island.
Okay,
so
so I don't know the study that you're talking about with the CO1 gene and this 2018 study. I'm familiar with like the bar coding study that like Donny's brought up before about this, supposed universal bottleneck. I mean, I can address that, but what I'm interested in is, are you saying that it was essentially random? And I can't really comment before I do this. I can't really comment on like God not conceptualizing marine life as life. That's news to me. I didn't know that. But like,
Matt, are you saying God? Are you saying God would look at a blue whale or a dolphin and not consider that life?
Like an octopus, they're pretty smart.
Yeah, I don't.
There's tongue there, or
the best to me. God looks at life spiritually, and so he's looking at life like animals have a part of the spirit inside of them, because they have the breath of life. It doesn't mention that fish have this. So my guess is that God doesn't look at them as life. So I've been viewing this very differently lately, going, wow, I wonder if fish were even dying during creation week, because God doesn't even consider them life, just like he doesn't consider that plants life. Very new concept for me as well. I'm pondering it a lot.
Are you including whale, like marine mammals in that category?
Yeah, because there's no ocean in the next life. God's not resurrecting anything that's in the ocean in the next life. It says the ocean is done away with. So why would it be life if God's not even resurrecting them? He doesn't care about them. They were made for him. That was it, for the beauty of the world, for us.
Go ahead, Grace.
Yeah, I really don't know what to say to that. That's all new information for me. And since I'm not a religious person, I can't really comment about like scriptural stuff or God stuff. But um, just in terms of like the mechanism for how a heated ocean takes all the species that have ever existed in the ocean and narrows it down to just the modern species. Um, I
Well,
don't see how that could happen. Like if you just like I don't understand how that mechanism can happen unless you're just saying that like it was just totally like random, but like how does it differentiate between, this species died off, this species survived? Like how can you predict which species would survive and which would die off? Is there any rule or is it just totally random and arbitrary?
this one's easy. They're only modern because they survived.
So you're saying that it was essentially
It's
random
just
which ones
random.
survived.
They just the ocean was dying. 90% of the life on it, just like 90% of the life on land, died. Eradicated.
So usually, like when we have a big catastrophe or something that kills off a lot of species, like a mass extinction event, there is some unifying quality that the survivors have that those that died off lacked. Or like, for example, like, and again, this is just a scientific consensus. I know you disagree, but this is just an example. Like with the like the dinosaurs, right, dying off. All of the large species on Earth died off then. At least that's the scientific consensus. Only the small ones survived. So, like, that at least is a criteria as, like, oh, okay, if you're small enough, you could survive it. If you're large enough, you're going to die. If we extrapolate that kind of logic, it doesn't seem like there's any kind of rules like that that would apply to all the modern marine species about why they survived that doesn't apply to the extinct species. It doesn't seem like there's any way that you'd be able to say, like, oh, well, it makes sense that a whale and a krill both survived these superheated oceans, but that's why Megalodon died out. You know what I mean by that? Like,
Yeah. But actually, we do see a lot of large animals surviving what we would consider after the flood because of the Ice Age. Mammoths grew much larger. Saber-toothed cats were gigantic. Dire wolves existed, huge, right? The Ice Age made things larger than it actually is today. As we warmed up, as everything started to stabilize, boom, you get smaller. So we would say that like what was killing the megalodons as opposed to leaving the whales, probably just based on where they were in that environment at the time. And if it eradicated, all it had to survive was just a couple, right? Or one pregnant one. That's all it needed to survive. So
I think you need a little bit more than just one pregnant one. But yeah, you need a population of some certain size to not go extinct. But
right.
I don't know. I think we're kind of going off topic. This is I don't think this is on the age of the Earth anymore. But
it usually goes there on Q&A. Yeah.
Yeah. So
well, I wouldn't consider this Q&A. It's still the discussion. I was just throwing a couple curveballs in there. And so to leave no stone unturned on the age of the Earth debate, if you both still wanted to talk about the dating methods, of course, but I've noticed a couple of the genetics related points brought up. Did you guys want to go back and forth a little bit on whether or not the genetic data or the biological data supports a young Earth or an old Earth?
Sure.
It's up to you if you wanted to go into the genetic boundaries or molecular clocks or something like that.
Sure.
That's up to you, gentlemen, but that might be something the audience would enjoy.
Yeah, I don't know. That sounds like a whole other discussion. I know, Donny, you and I have had hour-long talks on just molecular clocks. So I don't know. We're at like an hour and 40 minutes already. I don't know if we're trying to get to a Q&A and not be like a 3-hour debate. I don't know if we want to go into the whole genetics of it, but I don't know. I'll let Matt decide.
You know what? So I guess the main genetic related point that was brought up, Matt, I think you brought up the CO1 gene and the genetic boundary study. So maybe we'll just kind of focus on that point, Matt. Or we can do this, especially for the audience. I think this would be beneficial in our last remaining minutes. Let me see how long we have for the discussion. So in the last remaining minutes, we got a few minutes left. Matt, let's hand it to you. Choose a line of evidence that we've kind of discussed today, but explain why, from your position, this is a discriminatory line of evidence. So everything that you both have talked about, Matt, point out something that you believe only the creation model that you're proposing can explain, and then we'll have you both engage it a little bit. I think that would be good in light of the affirmative tonight. So Matt, go ahead. We'll start with you. We'll go back and forth on that for a little bit. Then we'll get into some audience questions.
Sure. I again would like to go to the formation of the lead. You get both normal lead and radiogenic lead, but when it's formed in the laboratory, again, it's formed on Earth. Now, the amazing thing is it solves the paradoxes that they keep having. They look and they find radiogenic lead that they don't think should be there because Earth has to be 13.9 billion years old to create that much lead. So they said, man, we don't know what to do with this. There must have been accelerated nuclear decay. I can be okay with that, but the evolutionary model, not so much, because they don't like our model. So it's okay, but we don't need to invoke it because of the new laboratory experiments. So I think I solved both unique concepts from just lead alone, and I haven't even gotten into the other ones. So I think that it's a unique perspective from the young Earth creation model that we've never had, where we've actually considered what do the elements look like when they're formed, and what do the radioactive elements look like when they're formed, because that's how we date the Earth. And so obviously with aluminum 23 having such a fast half-life and it forming in the same ratios, I would say that to me is very good evidence and helps with the paradox problems that we have with it. So that would be me.
All right. Well, like I said before, I mean, ultimately the source for most of the elements on Earth was from a plasma in stars. So it would make sense to me if those ratios are similar that we would get from similar processes using plasma. So I need to look more at the specifics, obviously, but I really don't understand how this is any kind of a gotcha or discriminating lines of evidence, because it sounds like this is totally within the consensus picture. I don't think that those authors thought that this challenged the scientific consensus. I don't think that the reviewers thought it challenged any of the scientific consensus. I mean, it's a cool experiment, but again, I don't know how it would go towards any kind of line of differentiating evidence for the age of the Earth. So, I mean, he talks about the lead paradox. To my knowledge, that was just, why is there like more lead than would be expected in like the mantle? I don't think it was talking about like, why is there more lead that we would expect in the universe? I don't think that's part of. I don't think that's what the lead paradox is. So it would make sense if, like, you know, I mean, how are you differentiating between what's radiogenic lead and what's lead that was already there? I mean, and again, I understand how people in the audience can think that that's like, oh, well, you could just apply that to radiometric dating. But no, like we've already gone over extensively in this debate, zircons do not form with any appreciable amount of starting lead. So that's why we know that the lead in zircon crystals specifically came from radiometric decay. So again, but in the lead, when we're just talking about the lead in the mantle or like the lead in the crust, I mean, how do you know if that has to be coming from radiometric decay, or if that came from being formed in a star and was present in the accretion disk in the formation of the solar system? So I don't know. I don't think that this is any kind of line of differentiating evidence or any kind of gotcha. And most of like the things that Matt himself cites that discuss the lead paradox, within those same articles, they're proposing potential solutions to it. So it's not like it's like, oh, we have no idea. Like there's a ton of ideas about that would be naturalistic explanations for the amount of lead that we observe. So again, I don't think that this is differentiating line of evidence like Donny was asking for.
Thank you, Grayson. Matt, any thoughts on that?
I would say that, of course, they have rescue devices because to them it doesn't make any sense. So they're going to come up with solutions no matter what, but the solutions cause more problems because, again, they went down to the bottom of the ocean and they were like, whoa, so much radiogenic lead. They go, there's too much to be there. So the core of the Earth must be non-radiogenic. That's where it all went. It must have sunk there, and that's why we don't find it on the crust. They said, well, for us to solve that problem, we have to say that the Earth formed 100 million years after the universe was created. That was the resolution. So yeah, it's a rescue device. And yes, it has a naturalistic answer, but now you have to make Earth 13.9 billion years old. Or you can just look at the observational study and go, oh, it just formed recently. That makes a little bit more sense. The studies show that the Earth isn't billions of years old. And the reason why the study didn't do that is because it's not a study. The laboratory is a private organization that wants money. They don't care about evolution or creation. They're like, make me some money. So they're trying to create these isotopes now in disproportionate ratios. They're not trying to create them in the ratios that are on Earth. They're trying to do the opposite. So they stopped striking the copper. They're hitting like lead and rocks. They're hitting everything now. So they want money. They don't care about this subject.
Okay, well, I would think that in order for something to be classified as and written off as just a rescue device, rather than like an answer or explanation, the difference between those things, to me, maybe Matt has a different conception, but if one of them has empirical evidence to support it, I would say that's an explanation rather than calling it a rescue device, right? So if these proposed solutions that describe why we have the amounts of lead that we observe in the ocean or in the mantle have empirical basis to them and have evidence supporting that those kind of mechanisms really are plausible, then I would not consider those to be rescue devices. So I would, I agree. I would think that's just an explanation.
Oh, no, I agree. But the fact is we've just drilled through into the mantle for the first time ever. And I know my opening was intense, but I showed that it had to be a rescue device because they were expecting tons of lead and non-radiogenic. They found less lead that was radiogenic. So that to me, but then again, they didn't know that, of course. That prediction that the core must be pure non-radiogenic lead was predicted as the solution or the hypothesis of why there is more radiogenic. I use the red rescue device because I found that the new evidence falsified their hypothesis that would have rescued it. So to me, the concept of all they have to do is accept the observations of the new experiments, and we solve the paradoxes. But unfortunately, now you have to be a young Earth creationist.
I don't think that that's necessarily the case, but I will.
It's okay, just be one.
Well, I would like to look into this study that you're talking about where they sampled like lead in the mantle and it was dramatically different than expectations. I'm not aware of that, so I would need to read it first, but I will read it after this and I'll let you know my thoughts or maybe make a video about it. But I can't really comment on it without specifically looking at it. No problem.
It only came out 1 week ago, so not many people know anyway.
Oh, okay.
Brand new. Yeah, they finally they went down to like the deepest part of the ocean and then drilled down and broke into the mantle.
Well, that's very cool. I'll be interested in reading about it. So I will be reading about it and then I'll let you know my thoughts afterwards.
All righty.
Gentlemen, great discussion. We've had an excellent audience, very lively live chat. And we have a ton of audience questions, but also comments. And so let's just, if it's okay with you gentlemen, I think we were comprehensive. I think we touched on basically all the points. Correct me if I'm wrong. And we can kind of go back and forth on some of these audience questions and comments. And so we can engage those as well. We'll be interactive here, maybe a little more interactive than usual. And so, okay, let's move right into I guess this Luca Medugno. Appreciate your comments and questions tonight. Luca is asking you, Matt, if you can show us. He's curious about the lab in Ukraine, I believe it is the Proton 21 laboratory. If you have any data on that, or
oh yeah, I will give everybody a link in when this is done to like go and see. They're on ResearchGate, academia.org. They just post papers but they're a private organization, so you can email them, but they're in a war right now. I don't think they're going to email anybody back. So you're going to have to be stuck with the papers that are already found on those. But yeah, that's a good idea. I'll post a link and then you can pin it when this is over, and then everyone can just go and find these things.
Okay. All right. So we got one here from.
And I just want to say, people are saying in the comments, they're saying we did not drill into the mantle. So again, I haven't read it, but people are saying that we did not drill into the mantle, but that's only the comments. I don't trust the comments.
It's okay. You can share. You can share a screen. I'll show you the thing.
Yeah, well, if you'd like, because as I said, we are being a little more in. So this has been a very free-flowing debate, as it's an important topic, and we're engaging each other's points, challenging each other, and so we're getting the audience involved too. So Mark Reed specifically says this, if you wanted to give your thoughts to this, Matt. He says they drilled into a place where there was seafloor spreading between plates, highest mantle rock. It was still rock, not magma.
Right. It was a type of, there's a rock inside of a rock. It was a particular, it's all black, and it's from what I understand, it was still rock, but they were able to get a percentage of different elements from it when they were able to test. And so that's the deepest we've ever gotten. And of course they're not going to be able to hit the core, but they at least broke the crust for the first time ever. And it was a type of rock that's inside of another rock. I forget the name. It starts with a P. I'll think of it in a minute, I'm sure. Periodite. That's right. It's an igneous rock that's made of minerals of two different types. And it's the most common type of rock that's in the upper mantle. But they tested the lead using a technique called ICP-MS. And you can read about it online, because that's how I found all this. Because I started reading the different articles. Of course, there's tons of them, but it was for this debate. I thought I would look it up for the lead paradox.
Okay. Appreciate it, Matt. T-Rock, question for Matt. If
T-Rock has a question for Matt?
What? Yeah, look at that. He's coming at you, Matt, rather than Grayson. I guess he's had enough discussion with you over the last year or two, Grayson. Don't feel too bad. So T-Rock is asking, if supernovas formed uranium, you guys were chatting about this early on in the discussions when this question came in. Did they not also form lead at the same time, giving a false age at the time of their formation?
It would, if it was the exact same as the experiment. It would probably show a false sense of age for sure. Yeah, because that's what the laboratory did. So I have no doubt if it's mimicking a supernova, then yeah, it's going to be forming all of the different radioactive isotopes, like that little clock that I made with clocks inside of it. That's what it showed. That's what was so peculiar, and to me made me think like, wait, we can date the age of the Earth with this. What portions do they thing in? So getting a hold of them is the hardest thing. So you're kind of stuck with their experiments that they've posted. But yeah, when you read about it, yeah, you see the proportions that they are today, not as they would have been billions of years ago. So to me, it's kind of a case closed thing on, well, the Earth must be young, simply because if deep time did pass from the ratios that we have right now, then we would see massive amounts of the daughter isotopes, but we don't see those levels.
Thank you, Matt. Grayson, anything you'd like to add or rebut or anything like that?
Yeah, so lead did form in these supernovas along with the other heavier elements, gold, silver, uranium, palladium, whatever. But like, again, we know that this does not give a false age for uranium lead dating because we date them with zircon crystals. Zircon crystals are not formed in supernovas. Like, sure, you can have the uranium in them formed during supernovas, but the zircon crystals themselves don't form in supernovas. So we're dating the formation of the zircon crystals, which we know do not form with any substantial amount of lead in them. So we covered this to death in the debate. I don't know if T-Rock just missed that part, but that's why it is true that uranium and lead are formed in these stellar processes, but that does not affect the veracity of uranium lead dating of zircons.
Thank you, Grayson. Matt, any thoughts?
Well, if he just joined in, then I recommend rewinding because yeah, we did touch on that. I explained that I think that those elements got into the zircon crystals early on when they were first formed, and that's why the massive amounts of proportions of daughter isotopes that form in these studies rapidly would have decayed into the lead that we find in the zircon crystals, which would have given the appearance of a lot of age passing by, as where the young Earth creation models mostly explain it through accelerated nuclear decay. I'm going by the observational experiment for me.
Okay. Thank you, gentlemen. Apologetics 101.
Wow, all the questions are for Matt.
Matt's in the hot seat tonight. And so it's a little bit of peer review or audience review, we could say, Matt. Okay, so Apologetics 101, Brian, thank you for the feedback and questions. He says, Matt, if you don't support accelerated nuclear decay, do you have a possible an alternative trigger for the flood? Some flood models use accelerated nuclear decay for a trigger for the flood itself.
Yeah, I think accelerated nuclear decay mostly occurs from the catastrophic plate tectonics model. Walt Brown's does not. His is the hydroplate theory, and he uses supercritical water to form a piezoelectric effect when the continent falls down to create the super heavy elements that rapidly decay into the elements that we have on the Earth. So his heat wasn't coming from accelerated nuclear decay. His heat was being generated from the formation of these elements. And so if you want to use Walt Brown's model, you can literally get rid of all the heat generated simply by using the plates that were on water that is no longer there because it was pushed up onto the surface of the Earth as the shifting began. Or there's another model as well that talks about when rocks are heated, they grow in about 10% in size. So you get kind of like a coasting of the continents, the crustal ocean that moves like an iceberg over water. There's a lot of different models that don't use accelerated nuclear decay. I think it was just mostly because they wanted to account for the high amounts of helium in the zircon crystal. And he said the best way to explain that is accelerated nuclear decay. And so they posted it at the flood, or 1 to 2 billion years at the flood as the trigger for that. There's no reason. There's lots of things that it can invoke massive amounts of seafloor spreading based on the old continental crust that is subducted, because it's a different type of rock that we can see when we look at the cold subducted rock that's there.
What got the plates moving at the meters per second movements at the time of the flood, Matt?
Well, I would say that when we look at the Mid-Atlantic Ridge, we find places where it's miles high. So anytime you're getting an uplift in that region, you're getting a region where things would be moving in the opposite direction at about the same amount of time. So if the uplift was rapid from that event, you're going to start the movement of those plates in the opposite direction. So that's why I think when you're looking at mountain ranges, you find mountain ranges that are just as high right off the coast, deep. So that's why they're the same height as one another, because you're going to get the height of the mountain and then you're going to get the depth of the ocean when they're colliding. And that's why. As far as the start of it, yeah, I would have to say that both models, again, are a little bit different. Walt Brown's would be that the water came out of the Mid-Atlantic Ridge, and as it ripped through there, very high, tremendous power, it created like a ramp, and the plates started subducting and moving that direction, and they only subducted at the very end, creating volcanism. And then catastrophic plate tectonics says the Mid-Atlantic Ridge, the fountains of the Great Deep, are actually lava. It's not water, and that erupted, and that's where the heat went out, because it melted the ocean above it, so it could have just convected the heat into the air, not going into the ocean itself. It was one of the ways that they got rid of the heat problem, and that started the plate subduction because the rocks themselves were different. They were a type of very cold, dense rock, so it subducted very rapidly on its own.
Okay, thank you, Matt. Grayson, thoughts, rebuttals, anything you'd like?
Yeah, well, I can't really comment because of the veracity of the different flood models, since clearly I think all of the flood models are incorrect. But just and also, I also don't get biblically this question, because, like, again, not a Christian over here, don't know, but it isn't the trigger for the flood just that God wanted to do it at that point? I mean, like, he said, like, everyone was being too sinful or whatever, so he flooded the earth. That would be the trigger.
Right, so, but the Bible says that God used the earth to destroy. So he didn't say that he caused some type of thing. It says that he used the earth to destroy man. So the earth itself was used as the trigger. That's why.
I don't know. To me, that still doesn't say that. I mean, if I use something to do something else, I mean, I'm still the one that's choosing the timing of when I use it. So whatever. I would just think that God is the trigger. I think that should be a satisfactory explanation for most Christians. But just in your point about the super fast like seafloor spreading and the movement of the continents being fueled by like super fast like uplift along the Mid-Atlantic Ridge or whatever, I think that if you were going to have that much force, right? If you're going to say, oh, the uplift is happening this fast to cause the seafloor spreading to be this fast for the continents to be moving that fast. If you're going to have that much force and energy that it would take to actually cause the uplift to happen that fast, I think that would basically just result in like an explosion, and you're not going to get the nice ordered seafloor spreading. I think it's just going to like, there's that much energy in that amount of small place. I think you would basically just be melting the rock at that point. You'd be having a massive explosion. I don't think it would get this neat little ordered uplift and seafloor spreading that you're saying with those amount of energies in order to get those amount of speeds. I think that it would basically just like blow up with several orders larger than any nuclear bomb that's ever been detonated, and it would just literally melt everything involved rather than causing this really fast movement of continents.
I could give you stuff that shows you the math behind that, because there's people that have done that. Like Walt Brown is an engineer, and when he formulated the movements, he ran the numbers on that. So I can give that to you if you want.
Yeah, I'd be definitely interested in seeing those calculations.
Okay, all right.
You have my email, I think.
So here's a follow-up, and this has been great. I think we're really touching on a lot, and that is our goal with a lot of these debates, is to make these debates on these more specific topics go-to debates for people really interested in seeing both sides. And so Apologetics 101, this is a follow-up. He's saying CPT, or catastrophic plate tectonics, as a flood model, claimed the great fountains of the deep was lava. So can you maybe speak to that a little bit, Matt? Is there a difference in what the fountains of the great deep are with CPT versus HPT, or even with the model you're proposing?
Yeah, I know. I was shocked to find that out too, because I had been studying flood models for quite a while, and then I started really reading through the technical information. And yeah, catastrophic plate tectonics invokes that the fountains of the great deep were lava, not water, and that the water that flooded the earth came from the water that was already pre-existing on the earth, and it flooded the continents because the continents were only 4,000 to 5,000 feet high pre-flood, and that tsunamis are what did it over the process of about 3 months until eventually they were submerged, and then 3 months at the end when the water started receding back into the back underneath the ground, which got locked up into ringwoodite. So they did, yeah. There's different concepts. Walt Brown's was that it was water, and that's what the hydroplate, right? They were on plates that were suspended a lot by water, and then eventually the moon, the gravity pulled it, and the continent of the entire United States cracked, and the Earth cracked like an egg, and the continent of the entire United States fell down 1 mile. And it hit, and when it hit, it exploded and created the mid-Atlantic ridge around the entire world and ejected debris all the way up into the moon. So totally different models, but both of them are catastrophic. Yes.
Thanks, Matt. Grayson, any thoughts?
It just sounds like the equally crazy fantasies to me. So I don't really have any thoughts on that.
Okay, thank you. Mark Reed, he's got a question, and might as well give a shout out. Mark Reed and Matt, they're going to be duking it out in the debate octagon coming up now in a couple weeks. And so if you enjoyed this one, you'll definitely enjoy that one. Mark and Grayson, I would say, are two of the more prominent debaters on in the creation evolution world. So this is going to be fun. Is there scientific evidence for evolution? So rather than the age of the earth, it'll be specifically evolution. So for a little context, firstly, this has been a lengthy debate, and Matt and Grayson have already discussed the heat problem in detail. But I'm going to kind of add something to this too. So firstly, Matt, have you solved the heat problem? If, according to your model, there's no excess heat and radiation produced from accelerated decay, what about the heat produced just from meteor impacts, or as Grayson was pointing out earlier, correct me if I'm wrong, Grayson, the rapid plate movements, the meters per second movements of the plates during catastrophic plate tectonics would generate a lot of heat as well. So even aside from accelerated decay related heat and radiation, what about just other related catastrophic processes? So feel free to kind of touch on all of that, Matt.
Yeah, most of the heat generated in these models, or let's just stick with CPT, was generated from accelerated nuclear decay. There's no doubt about that. As far as me solving that problem, it can't be. I think Eugene Shafton, the mathematician that worked on the Ray team, showed that it couldn't even have been done in the first place. So I'm going to say that there are different forms of heat that would have been generated, mostly from convection heat. And the convection heat, I got a mathematician to come on, and he ran a simulation model showing catastrophic plate tectonic heat generated from the different forms of heat on my channel. I even put it on this one, but it was quite some time ago. And it shows the heat that would have been generated and how it could have been resolved with different measures, and have still generated heat, there's no doubt, but how it would have been dissipated and resolved with different concepts. So resolving catastrophic plate tectonics, I don't think it's possible, because they said themselves that it's not possible. So they their heat problem is always a heat problem, and the math shows that it can't be done. So I'm going to stick with what I'm seeing in the laboratory is my answer. And if you want to invoke accelerated nuclear decay, that's fine, but you have a limit, and a few million years. You don't have billions. So that's the unfortunate part. Plus, if you want to invoke accelerated nuclear decay, you're going to melt the continental crust, and we still have granite. And granite, when it melts, turns into rhyolite. So it actually couldn't have worked based on the rocks that we see. So I guess that's I can't solve what isn't solvable, but I have a replacement.
Thanks, Matt. Grayson, over to you.
Okay, so I agree with what he's saying about accelerated nuclear decay not being like feasible physically. I think that in terms of the mechanisms for how the heat is dispersed from, like what you correctly brought up, Donny, with like the catastrophism, the super fast movement of plate tectonics is going to generate a lot of heat as well, just radioactive decay just beside. And Matt just said there are mechanisms to dissipate that heat. I didn't hear what those mechanisms were. He just kind of claimed that there are mechanisms for it. So yeah, I mean, I didn't actually hear any proposed.
That was my bad. I try to go. Sorry about that. I try to go fast on Q&A. My bad. I go real quick when I answer things. So I didn't want to go into a big old thing. I could just upload a video for everybody when this is over.
Okay. Because I mean that is the question that was asked, was how do you solve the heat problem? So you're saying that we're not doing accelerated nuclear decay. All the decay and all the heat was in the creation days, and God just, miracles.
Oh, no. No. The heat problem only comes down to accelerated nuclear decay. So I answered that by saying, I'm sorry, I can't.
But there's another heat problem, which you still have in your model, right? From the super fast movement of the tectonic plates. That's a new heat problem, because that also emits a lot of heat that you have to dissipate by some mechanism.
Right. Okay.
Yeah.
So
Actually, if I could reiterate, so basically, and again, correct me if I'm wrong, Grayson and Mark are arguing that the Genesis flood must have resulted in, because of the drastic geological changes, which would involve extremely energetic processes during that year-long flood, they would have also generated an enormous heat load.
And also just besides just the plate tectonic movement, I think Matt also said that there was a bunch of material that was ejected and made all the impact craters on the moon, and then presumably now fell back to Earth and made all the impact craters that we observe on Earth, because there's like thousands of impact craters on Earth. So if all those happened during the flood, that would also be another source of a lot of heat. So you've got multiple sources of, like, you still have a heat problem, even if it's not coming from radioactive decay.
Go ahead, Matt.
Okay. The accelerated nuclear decay wasn't in Walt Brown's, but the heat definitely. Okay, let's say that his model is correct, and it ejected a whole bunch of meteorites or debris back that fell back to Earth. In every layer of the fossil record, we've only found about 200 impact craters, even fossilized one. So we don't have millions. That's an interesting part that you brought up. If the Earth was created from bombardment of meteors, you think we'd find more, but we actually don't find too many. And then the heat, okay, let's say we go back to catastrophic plate tectonics, the heat would be from convection. So there was a program that was already run to show like how are the continents where they are. They showed that it actually moved about over a year, and that was a secular study into where they are today. So we believe that it already happened that way. We just have to answer the heat. So we would say that right over the mid-Atlantic ridge, it could have easily melted taken the ocean water that was above that and burned it away. So now it has access to the atmosphere, not the ocean. But then you have convection that's going underneath, which is creating volcanism, and that heat is going into the ocean itself. Now, how much heat that would have generated, it's been done. Catastrophic plate tectonics did run the math on that one. I did not, because I just was fascinated in reading the study, but I can get back to you on that one. That would be where the heat would be coming from, that would be dumping into the ocean, and how I would probably explain that most of the aquatic life died. Those subterranean convection areas still exist today, I think, for the most part, and they're around the Ring of Fire. So they're above ground now.
So Noah's Ark was made of wood, right? So if the atmosphere and the oceans are being superheated, you don't think that would cause a problem for a wooden boat?
Yeah, I just think that the amount of heat generated is what matters the most. And if the heat is taken away from the radiometric acceleration, then you just have this convection heat. So we would have to know the type of the subducted ocean floor. I don't know what type of rock it was. They know. I wasn't trying to resolve the heat problem. I was coming in to replace it today. So I didn't really come for that one.
Yeah,
but
that's fair enough that the topic was not the heat problem, but you have to admit you still have a heat problem. It's from like the catastrophism that you're bringing up. It's from the fast movement of the tectonic plates, and it's from all the impact craters. I mean, even 200, like you're saying. I mean, it's more than 200, but even just that's a lot of heat that would be heating up the atmosphere and the oceans.
Yeah, we agree that there was definitely some heat, but I had a video, or I had a guy give a 20-minute presentation on just the math for the heat. I've programmed it a couple times. It's in my playlist, but I'll bring it and upload it on this channel so you guys can see the heat. The numbers have been run, so there's an answer to it. I just don't have the capacity right now to throw it all out there for you.
Okay, gentlemen, I'm glad we've spent a lot of time on the heat problem issue, as there are many, skeptics, of course, that would argue a heat or radiation problem precludes young Earth creation in general. So this has been very good, and the goal is always to get a lot of information in there for the audience to enjoy and to learn from, basically.
I think, Donny, it's time for you to ask me a question.
Yeah, you got one.
Grayson, you read my mind. So a super chat just came in, and I'm looking at the questions. I've got 35 saved, and the majority are for Matt. So Matt's in the hot seat tonight. It's interesting to see. So, but this one came in, $10 super chat from Pseudonym. And so Grayson, here we go. You're in the hot seat now. So he's saying, geologically speaking, what's the problem of the crust, or what's the problem, the crust opening and giant splashes of fresh water to form of flood, guessing a flood? What's the explanation of meteors and freshwater fish relating to the age of the Earth?
So I'm really trying to understand this question, because they did a super chat and everything. I'm really genuinely trying to understand what they're asking here. I think they're asking, like, geologically, what is the problem with the flood model of like the crust opening up and like the huge amount of water spewing out, right? That's what they're asking in that first question, is like, what's the geological problem with that? Well, there's a lot of geological problems with that, but the first one that, like, and I've had debates on this channel before. I just had like a back-to-back debate on it, but it's the fact that we have a fossil record, like a geological record, and it is in an observable order. And a flood cannot produce the order that we observe that in. Like hydrologic sorting, which is what would happen in a flood, is not sufficient to explain what we observe in the geological record. So that's like one of the biggest, most glaring problems that I see. I've had debates on this issue, and I didn't get any answers in those debates. And you're free to watch them. If you think that they answered that question, go ahead and explain it to me, because I don't think they did. And the second part of that what is the explanation of meteors and freshwater fish relating to the age of the Earth? To my knowledge, I really don't know what you're going on about. I want to treat this in good faith, but I don't know about meteors and freshwater fish relating to the age of the Earth. Maybe they're talking about how does our previous conversation where we were talking about how the different fish species in the ocean survived a flood, or I really don't know what they're asking about. If Matt, if you have an idea of what they're asking, maybe you can elucidate it.
Ooh, good question. I was kind of stuck on that one too.
Maybe if Pseudonym can rephrase his question and ask it again, I don't know. But
I got the first part.
I tried my best.
The second part, again, I would say that he's probably asking you, how come there's so few meteor impacts? I said there's maximum of 200 fossilized meteor craters on the entire Earth. You said, no, there's way more. I don't know of that. I've looked it up, and there's not many. So Google away.
Okay, we got another one for Grayson. Joey Jesus Freak, thank you very much. Question for Grayson. So since we had quite a few for Matt at first, now we're going to throw some questions at you, Grayson. So he says or asks, if the Earth is losing about 10% of its magnetic field, one of your favorite topics, Grayson, every 150 years, how can you account for 4.543 billions of years for the Earth?
Yeah, it's super easy because that's not a linear rate, right? I mean, the strength of Earth's magnetic field fluctuates up and down throughout the history of the Earth. It's not just a straight line going down, right? So that's the explanation for that. Inherent in this question is the assumption that the rate has been constant this whole time, which is a fair assumption for radiometric dating, like we talked about, because it's based on more fundamental physics, where you can actually calculate what that constant rate should be, and you can explain why it is a constant rate using quantum mechanics. But in this example, there is no physics that you can rely on to say, well, the Earth, like magnetic field, is just constantly going to decay at a rate of 10% per 150 years. Like that, there is no physical mechanism to explain that. The current consensus model is the geodynamo model for how the magnetic field is generated. And the generation is from convection currents within the inner mantle or whatever. So those can be variable, right? The convection currents change over time. Earth's magnetic field strength fluctuates up and down. And this is observed in the paleomagnetic record. So we can see, like, when rocks form that contain iron, they align with Earth's magnetic field at a certain percentage based on the strength of that magnetic field. So we can see, just geologically speaking, that the strength of Earth's magnetic field has gone up and it's gone down over time. It fluctuates. It's not just a constant linear rate like the question implies.
Thank you, Grayson. Matt, any thoughts, rebuttals, counters, anything you'd like to add?
We as young Earth creationists say that when that decay gets down to a certain point, there's a flip, and a lot of those flips happened during the flood. So, but it's just, again, our perception of, we noticed the decline as well, but we see we give a different explanation, but nonetheless we see a rapid decay, and we see it in a lot of different things.
Last word, Grayson?
No, I mean, I spoke my piece. I think, I don't think Matt is agreeing that it's a constant linear rate of magnetic field decay. So.
All right, perfect. Dr. Dino, $5 super chat. Thank you very much. He says, I'll be hosting an after show for this on my channel. He says, open mic, though the debaters will get priority, of course. Hope everyone's having fun. Yes, we're having a blast. And Dr. Dino, we had a good chat during our open mic last week. So appreciate the support.
I also just want to say that check out his channel, because he also has a video on the different topics for how we know the age of the Earth. So he has a video literally on this topic. He did a good job with it. So check it out.
Okay. Appreciate it, Grayson. And also thanks for the super chat. Okay. So next one comes in from George Bond, thank you very much, George Bond. Question for G. The rate team predicted the helium in zircon. The actual work was done by secular labs, he says. Any thoughts, Grayson?
That's not really a question. I don't know what he's trying to ask. Is he just trying to ask, is what he said true or false, or if I agree with it or disagree with it? I don't know if what he said is true, but I don't know that it's false. So that's all I can really say on it, because I'm not aware of any prediction of helium in zircon that was made by the rate team that was later verified by secular labs. So if he's got the evidence to support that, he's welcome to email me, criticalbasedinquiries@gmail.com. Send me the evidence and I'll look at it.
Show me the evidence. Okay, cool. Thank you, Grayson. Brian Diaz, thank you for the question. Question for both. So we'll get you both to answer this one. He says, elementary school math formula, doubling 8 pennies a day, shows the population fitting the young earth creation ratio. 195,000 versus 5,000 intelligence growth speed. 5,000 years, we blow out the previous 195K question mark. So maybe just speak to, it sounds like a population growth argument.
Sure.
We can start with you, Grayson. Go ahead.
Yeah, so there's 2 different kinds of population growth when we're talking about living species. They have R growth or K growth. I forget which is which, but one of them is logarithmic, right? Where, I mean, we would expect they level off at a certain point. And the other one is really only seen in viruses, where it goes exponential, like is what they're talking about, where it continues to double at each interval. And that's viral growth, right? The most like living animals and mammals that we see today do not exhibit that kind of growth pattern. And, you know, for most human existence, that has not been the growth pattern. You are constrained not just by how many kids you can have in one generation. It's not like populations just keep doubling every year. I mean, you're constrained by the resources that you have available. If you don't have enough food, you're not going to continue to double every year. I mean, and that should be intuitive to everyone. Human populations are not just doubling every generation or every time interval. That's just not how any of this works.
Thank you, Grayson. Matt, floor is yours.
Sure. Yeah, I would also say that obviously a population is indicative to the ability to them for farming. You know, you would have never got the Egyptians without them being able to harvest spelt and kamut, things like that, because they were able to farm for the first time and grow a huge population. But when everything else also is pointing to a very young thing, like when you start to look at all the different, mathematics and writing systems and the different things, it is very peculiar that they all have flood models and they all have math, and the haplogroups start to pop around the same time. So I would just agree with the very question, saying that, yeah, sure, it just aligns with our model. And we don't have to say that, yeah, sure, 195,000 years passed, and then they all figured out farming, and that's what caused them to explode. And they were trapped in Africa the whole time without figuring it out. But I would just say it aligns with a lot of the things that we already say. So the numbers are more in agreement on my side. So nothing to defend.
Oh, they're definitely not. And this is actually a very common creationist talking point that I hear all the time, that all these cultures on Earth, they all have flood myths. Absolutely not true. 100% false. I can name like 20 cultures that have no flood myth. Okay. Like, I mean, just the Aboriginal Australians is a good example. The Chinese have a flood where it was a local flood that the first emperor controlled. He got the flood under control. That's why he was like this great guy. So no, I mean, and also in Central Asian cultures where it doesn't flood, no flood myths. They have big global ice winter myths, right? And they say, oh, the god told him to go underground, not an ark. He said, go into an underground cave system, bring all the animals 2 by 2 because the whole world is going to freeze over. His name is Ema. Look it up. There's like numerous examples. Native American cultures, most of them don't have flood myths. But the main thing is that if a civilization lives in an area that floods regularly, they're probably going to have flood myths. And if they don't live in an area that has regular flooding, they probably aren't going to have flood myths. It's very, very simple, logical, and intuitive. And again, we can do a whole debate on this, and I could just keep coming up with examples that do not have a flood myth. So it's a misconception. It is not true that every culture on earth has a flood myth. That's just not correct.
Matt, any thoughts?
The fact that they share a lot of the same stories is pretty amazing. Don't you think that they would survive in a world and have animals coming to them, even with different names? The fact is, the Native American story from the Red Road, which was their first expedition into the New World, they brought a flood myth with them, actually. So, yeah, of course they're going to lose it. Certain tribes are going to lose it, but that's because they don't have a lot of writing systems. Native American tribes didn't write things down. So of course the game of telephone is going to get ruined over time. But the fact that so many do that supposedly had no contact with one another really makes you think that, like, wait, God decided to like flood that neighborhood. So I'm just going to invent a story about the entire world being flooded and bringing animals and saving. Very, very peculiar that they would all come up with that and then have the same biblical stories.
So they don't all come up with that. Only those that had contact with the Sumerian civilizations, such as Israel, such as Central Asia, those are the ones that have it, because ultimately it's a Sumerian myth, right? With Utnapishtim or whatever. That's from current understanding of archaeology. This flood myth originated in ancient Sumeria, okay, like the Enuma Elish. That's the conception. Where we look at cultures that had no cultural contact or preceded the Sumerians, we don't find a flood myth there. We don't find the animals in 2x2. We don't find any of the correlates. And I find this to be a very interesting topic. And also, you said that you can't really trust oral history because it's get all corrupted. There's actually, the consensus is shifting on that, just because of, like, they used to dismiss a lot of oral histories because it was like a Western centric kind of view of archaeology and anthropology. But when we've actually gone and we've examined some of these oral traditions and see how closely they match to history, we've actually found that they can be very, very accurate, and they can be passed down with relatively little corruption, like for generations and generations. The most impressive one, because you were saying about Native Americans, the most impressive one is, I think it's in Canada. So Donny, you'll like this. It's on the west coast of Canada, north of Vancouver. There's actually the native tribes there have like an oral tradition that at one point the entire earth froze over, not a flood, an ice age, except for one island that is known to them. They say that's the only island that didn't freeze over. And that's where all the people at that time lived, because everything else was frozen. And then guess what? They looked at that island, they found a settlement, and they radiocarbon dated it to the Ice Age, 14,000 years ago. So that is an oral tradition from 14,000 years ago that went today, that had accurate information and said, that's where the people lived during the Ice Age. They went, they looked, they found an Ice Age settlement exactly where the oral tradition said. So oral traditions can be pretty amazing at, like, not being corrupted over time.
All right. Thank you, Grayson and Matt, for both of your responses. Okay. We got one from another one from Matt now, from Creationist Crybaby CC. Thanks for the question. It's coming at you, Matt. So he says, Matt, some crystals incorporate the parent isotope while excluding the daughter isotope. Age is determined by measuring the relative parent to daughter ratio in a single crystal. And the question is basically to explain.
So if something is doing something very differently all the time, and sometimes they do and sometimes they don't, that doesn't really bring credibility to uniformitarianism. You kind of want a consistent basis to be able to trust something. To say that it's sometimes it does this and other times it doesn't, well, why would you trust that as a dating method? I'm going to have to go with what we see in the laboratory. And it seems to me that when it's observable, testable, repeatable, that's the way to go. Not random events in nature.
Okay, thank you, Matt. Grayson, any thoughts? Oh, Grayson, I think you're on mute.
Sorry about that. Yeah, this is basically what we were talking about with zircons. I mean, they incorporate with the parent isotope, but not with the daughter. And that is because of the crystal structure, right? Like the parent isotope fits in that crystal structure, but the daughter does not. That's why these crystals form without the daughter and only the parent. It's because it's inherent in the crystal structure, like at formation. So I think that that's the point that Creationist Crybaby is bringing up. And we've gone back and forth about that the whole debate. But yeah, when you're just looking at these individual single crystals that cannot form with any amount of daughter in them, only with the parent, then yeah, it's very straightforward that if you find daughter in that crystal, that it's from radioactive decay.
Thanks, Grayson. Matt, back to you.
I would have to go with the fact that there is so much helium in them. Then, if they had really gotten trapped and they decayed slowly over the millions of years, and you have rapid diffusion rates of such a light element like helium or argon, then helium has that diffusion rate of about 6,000 years or so, and there's so much in there. I'm sure it's trapped, and I'm sure it leaks out very slowly. But the fact is does it really take those billions of years? The young Earth creationist would say, that's why there is not much helium on Earth. But it lines up with how much should exist on Earth if it was very young. Otherwise, it would be nothing because it diffuses, goes in the upper atmosphere and evaporates.
Well, it doesn't just go into that. Okay, whatever.
It goes in the upper atmosphere, stays. I'm sorry.
Okay. The diffusion rates that he's talking about with helium are Humphreys numbers, which again, we talked about. There are reasons to believe that those numbers are not accurate. So the whole thing relies on the assumption of the diffusion rates of helium, which I've already shown you. There are multiple modalities of helium. There's tightly bound helium and there's loosely bound helium. And there's all kinds of problems inherent in the assumption that what Matt said is the correct and valid diffusion rate, which is, I would just say that's the wrong diffusion rate. So that's why his conclusion is wrong.
Back to you, Matt. Question was for you.
Everyone came home, so I'm sorry for the background noise.
That's okay.
It's probably going to get loud. I would just say that we're kind of going to go back and forth because I try to explain the reason why that we have these elements inside the zircon crystal to begin with in the ratios that we do is because of their formation and when they have been incorporated. They say deep time, we say recently in higher proportions of the daughter elements, and that explains why. Can they get in? Yes, they can. So the mere fact that they can at all is going to be able to show that be indicative of showing a clock that looks older than it should be. I don't have to invoke accelerated nuclear decay, but that would explain, again, a little bit of time passing. Just throw in a million years and you're going to get more helium.
I think that was planned out. That was Providence, where we've got Creationist Crybaby asking a question, and then we have a baby crying in the background, Matt. So beautifully played. Okay, we'll start.
Is coming from inside the house.
Yeah, Creationist Crybaby is watching the debate from inside the house. Okay. I knew you guys were a team, Matt. Okay, so we'll start wrapping it up. I've got so many questions and comments. We could do this till probably same time tomorrow. So I've got two questions that are basically the same. It's for you, Grayson. So let me just find it. Seem to have lost it. One from Apologetics 101 and one from Centurion. And the question has to do with, here it is. So it has to do with C14 and diamonds. I know you're familiar with this one. And so the question, to be exact, question for Grayson, again, this is a question from Apologetics 101, and then Centurion asked the same question too. So kill two birds, one stone. How do you reconcile the fact that C14 has been found inside diamonds, and given the fact that C14's half-life is 5,730 years, makes it less than 100,000 years old, question mark?
Yeah, so what's the biggest impurity found in diamonds? Nitrogen 14. What decays into carbon 14? Nitrogen 14. So there you go. It's not a big mystery in my mind, but if anyone's curious about this, T-Rock and I had an entire debate on this topic as part of our Age of the Earth big debate where we were jumping from topic to topic to topic. One of them was this specific topic, and that was my answer for it then. and also just difficulties in being able to measure the small amounts involved. But mainly, I would just say that the commonly known largest impurity in diamonds is N14. So.
Thank you, Grayson. That was a good debate. I recommend people check it out. Matt, any thoughts?
Yeah, we had somebody come on a while ago and give a presentation on showing that there could be no contamination. That was a good one. That was interesting. That would be something to either re-premiere or show the audience.
Okay.
I'm going to mute up again.
No worries. I think, let me just look at these questions. We could probably really start to wrap it up here, since we have been going for a while. And I will say this has been thorough. So this is exactly what I expected for this debate. This is what I wanted for this debate, for both sides to be comprehensive and really get the audience to think about these topics, specifically the age of the earth topic. So Grayson and Matt, excellent job to the both of you. I do appreciate this debate. I personally am looking forward to re-listening to it. And so let's wrap up the audience questions there. I think we've engaged audience questions for quite a while. To the audience, thanks so much for the questions and comments. It's been fantastic. Let's get some final words, final thoughts. So Grayson, we'll start with you. Thank you for doing this. It's been a ton of fun. We'll get some final words, final thoughts from you.
Yeah, well, I think I've done an adequate job of addressing the different points that Matt has brought up through the night, and, explaining them, debunking that they debunk radiometric dating or the age of the earth. So I didn't really see anything that was, like Donny asked for, a differentiated line of evidence that would be impossible in the scientific consensus old earth model that would be a positive line of evidence for young earth creationism. Several times Matt said that you can get millions of years but not billions, but I never really heard any explanation for why that is. Maybe I missed it, but I certainly didn't hear anything that said you cannot explain this in your model and we can only explain this in our model. I didn't hear anything that was like that. So he brought up the natural nuclear reactors. That's explained in the scientific consensus. He brought up polonium halo, or no, Donny brought up polonium halos. That's explained in the scientific consensus. He brought up like the lead paradox. There are lots of naturalistic explanations for that. I don't know if we have a consensus explanation, but we have lots of naturalistic explanations. And I don't think that's differentiated line of evidence. He brought up the experiments with Z pinching in Ukraine. Again, there's nothing supernatural going on there. There's nothing that is in contradiction with the scientific consensus in that experiment. Let's see, the clock analogy I think is a good analogy in certain circumstances, but it's not. The analogy breaks down when Matt tries to use it in the way that Matt wants to use it in. The supernovas, we talked about that. Again, the creation of super heavy elements is not differentiated lines of evidence that is explained within the scientific consensus as well. And zircon crystals by themselves completely debunk what Matt has been saying. So if Matt wants to address specifically how you get a zircon crystal that forms with any significant amount of daughter isotopes in it, that would be the burden that he would have to prove in order to show how you can have zircon crystals with the amounts of lead in it that we see today in a young Earth without a miracle. So it seems like Matt has moved away from accelerated nuclear decay and has kind of just gone towards, he says it's not just a miracle, but it really sounds to me like he's just saying God just did it this way miraculously. So I'll leave it there.
Grayson, appreciate the final words, final thoughts. It really has been an excellent debate tonight. So thanks to the both of you. Matt, we'll hand it over to you now. Thanks for doing this. And let's get some final words, final thoughts. Go ahead.
All right. The natural explanation was that, well, if these radioactive elements are being created in a supernova, then and I don't see the problem that they're on Earth at the same proportions. Well, that's easily resolved by the fact that if they're forming right now on a supernova, by the time they would get to Earth over billions of years, their decay proportion ratios from parent to daughter element would be drastically different than we see them on Earth today. So the fact that they're forming in the ratio that we're finding them in the laboratory that they are on Earth today, I think is absolute perfect evidence to show that the Earth cannot be even 1 million years old. We do that with one of the faster rates of decay, which would be the aluminum, but you can also do it with potassium. And then again, potassium shows that the Earth cannot be over 1.25 billion years old because it's also formed at the same proportions as today. So to say that it formed in a supernova in that same proportion and then got to where it formed on Earth, well, you would see that decay. It would be much different than it is today. So therefore, the observational data is what I'm going by. And that's what shows me that the Earth is very young. And why it's in zircon crystals is the mere fact that when they do form, you find massive portions of daughter elements that rapidly decay in minutes, hours, and days. And so if any of that got into a zircon crystal, it's obvious why we would find high proportions of lead, which is the daughter element of that. So I say, no, God did not do it. This formed naturally from a lightning, which would be a form of radiation that which would become hitting uranium and then creating all kinds of different elements. There's other ways that it could be done on Earth naturally, other than just forming in a laboratory. Laboratories just are representing what we try to do in nature. And since we go by laboratory experiments all the time for them to prove evolution is true, then obviously we should do the same thing with us. And what do we see? We see the radioactive elements forming exactly as they are, not as they were billions of years ago. So to me, it seems like a dead end for evolution. I can't see how they're going to explain that it formed from a supernova and then billions of years passed, but didn't show any of that time passing. So I won't go anymore. That's good.
All right. I'm sure Grayson's tempted to respond there, but we both got some points in. Final words, final thoughts. It turned into closing statements in a way, but that's good. It's been a great debate, and I'm sure we could discuss this all day. Maybe we'll do a round 2 in the future. So Grayson, Matt, thank you both for nearly 3 hours of your time. So to the audience, share this around. These debates are important, and I'm going to let Grayson and Matt out for the night so they can enjoy their Friday nights. I'm going to stick around for a little while and just go over some announcements and reminders for everybody as we have a lot going on. So Grayson, Matt, thanks so much. You guys are dismissed.
All right. See you later, guys.
Okay. Now it's just me and my awesome audience. So I've been pumped for this debate. I've been looking forward to this one for a while. Grayson knows his stuff. Matt knows his stuff. They're both excellent debaters. And so these are the kinds of debates that are debates to remember, I guess you could say. So the great age of the Earth debate did not disappoint. Share this around, guys. The reason we host so many debates on Standing for Truth, as I've said a million times, is because critical thinking is important, but it also gets us out of our theological and our scientific, in this case, echo chambers. It brings people of differing views, differing positions, different worldviews into the debate octagon or even the debate dojo, since we do a lot of open mics. And it gets us together, and it allows us to engage these different topics. And so it allows us to discuss these issues in a sophisticated manner. So Voice of Reason said, I needed this research tonight, gents. Thank you. Well, thank you. I appreciate you being here and also giving me the feedback. I love the feedback, and I try to do my best to read all the comments, that come in, questions, things like that. I'm always looking for different ways, different things to implement in terms of making these events and shows better. And so again, thank you very much for all of the feedback, positive feedback. Dr. Dino, if you want to shoot me an email real quick, and I can post so that looks like there's an after show on Dr. Dino, I guess you could say, his channel. So make sure to go over there and check it out and continue the discussion, all night discussion. So I did want to let everybody know that we still have one more show tomorrow. And so for the summer, I usually book events 2 months in advance. I want to make sure that we have between 4 to 5 shows a week. And when we have 4 to 5 shows a week, then I think that gives quite a bit of content for people to be edified by. So it's been a great week this week. As a matter of fact, we started the week off with our evolution open mic. We went about 4.5 hours. I had a ton of fun. A lot of guests joined. We had a packed house the entire time. A lot of different views, put it that way. And so, host wise, it was myself, Matt, Kent, and Sam. Kent stayed for about 2.5 hours, and then we continued the conversation for another roughly 2 hours. So if you haven't yet seen that, okay, I just got the link to the after show through email from Dr. Dino, and I just posted it in the chat. So there you go. My pleasure. No worries. Okay. And then we had, what did we have? Oh, there we go. We had Michael, the Canadian atheist, and Paul Price from Uncensored Pilgrims. Tons of fun, very informal. This was an informal discussion. This took place last night. As a matter of fact, is there evidence for the existence of God? If you haven't yet seen that, please do check it out. We've got another one of these conversations. We're doing a series of these more informal conversations on the God topic, the great God discussion, you could say. Is there evidence for the existence of God? Grayson will be back, and Paul Price, they'll be discussing that. Then we also had, today, I put out a technical presentation on eschatology, and I went over the various views of the millennium. I touched on amillennialism, postmillennialism, premillennialism. And so if you haven't yet seen that, please do check it out. That premiered earlier today at 5 till about 6:30. Tomorrow, Saturday night, Soteriology Showdown. And so we're mixing it up for you guys. We got a debate this week on God, the existence of God, discussion, I should say. We've had a evolution open mic. We had an Age of the Earth debate, and now we've got a soteriology debate. So we want to get a good mix in there for you. So tomorrow, another debate with 2 seasoned debaters, no strangers to the Standing for Truth debate dojo, as I like to say. Charles Jennings, CJ Cox. They're both coming and swinging. I can tell you, this is going to be a lively debate. This is going to be a debate to remember. I'm pumped for this one. They both know their stuff. They're both well equipped on this topic. And so specifically, we are debating James 2. And so this is the great James 2 debate. Essentially, what is the best exegesis or understanding of James 2? Very controversial verse. Ashley Meyer's sister says, enjoyed the discussion tonight. God bless. Jesse Christine says, before you leave, hit that like. Yes, don't forget to hit that like button. Make sure to hit that subscribe button as well if you're not yet subscribed, and share this content around. Help us get to 20,000 subscribers. We're close. And with your help, I think we can reach that goal by the end of the summer. Would be pretty cool. Anyways, we've got, I'm really pumped for this one. So Dr. Robertson Jenis, leading voice in the world of geocentrism. He's written a lot on this topic. He has debated this topic, and he's also put out presentations and a documentary, as a matter of fact, if I'm not mistaken, on this topic. And so he'll be debating Grayson. Grayson's also done a lot of work and study on this topic. And so this will be our first geocentrism debate. And it's going to be a good one. I can almost guarantee that. So that's coming up, I believe, next week. It's coming up very soon. We've also got Matt back in the ring. He'll be debating Mark Reed. Is there scientific evidence for evolution? And so that's coming up quick as well. And I've just booked several main events for the summer. So this is all just a snapshot of the overall material. If I went over all of the shows we have set, I'd be here for another hour. So I'm going to wrap it up with this one. This is the Great Millennium Debate. This is actually going to be in September, but time flies by. So this will be here in no time. So is the 1,000 years future? Pastor Anthony Aquino done a lot of study on this topic, and Dr. Don Preston, of course, has done a lot of study on this topic as well. They're both very professional, cordial. They both have had many debates, and this is going to be a huge debate, put it that way. Okay, so I think we're going to wrap it up here. Again, We had a ton of questions come in today, and I do apologize ahead of time. Oh, I apologize currently if we didn't get a chance to get to your question. Just the nature of these, I want to respect the debaters' time. And typically we've been going nearly 3 hours for these debates. And so these are long debates, they're comprehensive. And for these kinds of topics, I think that's important and also necessary. So with that, we're going to wrap up. We're going to wrap up this show. So God bless you all. Thank you again for tuning in, and Standing for Truth is out.